Okay.
Good evening, Ganapathy sir.
Good evening, ma'am. எப்படி
How
இருக்கீங்க?
are you, sir? நல்லா இருக்கேன் sir. How are you? Said YouTube. How are you, sir?
நல்லா இருக்கேன் மேம். ஃபைன் மேம்.
Settled down in NITPY, sir.
ஆமாங்க மேம்.
Family, sir?
ஃபேமிலி அங்கதான் இருக்காங்க மேம். கூட்டு
Okay,
போயிட்டேன்.
சென்னையில. ஓ, போபால்ல.
ஆமா. போபாலுக்கு கூட்டு போயிட்டேன் மேம்.
Okay,
உடனே
nice.
கூட்டு போயிட்டேன். அந்த அகாடமிக் இயர் முடிஞ்ச உடனே கூட்டு போயிட்டேன்.
Okay, good, sir. Settle ஆயிட்டீங்க இப்ப. எப்படி சார் போகுது ஒர்க் எல்லாம்?
ஆமா மேம். ஒர்க் டைட்டா போகுது மேம் ஏதோ.
Good, sir.
ஓகே. எவ்வளவு பேர் மேம் பார்ட்டிசிபென்ட்ஸ்?
736, sir. Good, sir.
736
ஆமாங்க சார். Praveen sir, shall we start now?
Once sir is shared his presentation, we can start, ma'am.
We'll check, sir, whether Ganapathy sir, can you please share your screen? Ganapathy sir?
Yes, ma'am.
The screen is visible now, sir.
Yes, ma'am.
Shall we start now, sir?
Yes, ma'am. Yes, please, ma'am.
Yeah, thank you. Good evening to one and all, and welcome you all for the day 4 ATAL FDP workshop of the session 7. Today's speaker, Dr. Ganapathy, is an associate professor in Department of Computer Science Engineering Education at NITTR National Institute of Technical Teachers Training and Research, Bhopal. He is recognized for his research and expertise in network security, deep learning, artificial intelligence, and medical image processing. And to his credits, he has been listed as one of the world top 2 scientists. Dr. Ganapathy has published and contributed significantly to research in his fields of interest with a strong citation record for key publications in wireless networks, intrusion detection, fuzzy systems, and machine learning. He is involved in designing and conducting both in-person and online training and diploma programs for technical teachers and engineering professionals at NITTR Bhopal. He serves as an expert for deep learning and related advanced technology courses and has contributed to MOOC and other national institutes initiatives which has been taken by his institute. Welcome you, sir.
Thank you, ma'am. Shall I start, ma'am?
Yes, sir, you can.
Yes, sir, you can start, sir.
Okay. Good evening to all. Today's session, the topic is Explainable Generative AI for Healthcare Decision Support. Okay. This is the today's topic. So, what are all the this session I plan to cover or the participants are able to obtain these two outcomes. One is differentiate the AI, generative AI, explainable AI, and explainable generative AI. That is the first outcome. Second outcome is explain the explainable AI for healthcare decision support. That is the role of explainable AI for healthcare decision support. These are all the two outcomes you will be able to obtain in the end of this session. So first we can start with the current status of the artificial intelligence. Everybody knows that wherever we go, the role of artificial intelligence is crucially playing in all emerging fields, especially in education sector. We are using in various programs also we are incorporating the artificial intelligence as a core subject in all discipline also. Like that in artificial intelligence, not only the education in all the emerging areas and even the public also, the many people are using the automatically the meta AI is incorporated in our WhatsApp, and so many roles are playing by the artificial intelligence. So healthcare is a very important emerging area. So in that it is very crucial also, very critical decisions need to be taken for the over the patient's situation, all the things by the medical doctor. Okay, so for the decision making purpose, so here the physicians are using the artificial intelligence technique for accurate decision. Okay, this is the major role. Nowadays, the increasing adoption of artificial intelligence in various healthcare domains. So, in this aspect, we can talk to that for enhancing the various domains. Okay, so AI is increasingly being adopted in healthcare to enhance various domains, and it assists in medical imaging and diagnostics. So medical data, various kind of data we are using, that numerical values, text data, or physicians reports can be analyzed, or image analysis is very important here in this medical sector. That is a crucial also. By seeing the image or medical image, X-ray image, or any CT scan image, anything at all, by seeing we may not come to the conclusion. As a physician also, it is a difficult task to come to the conclusion. So this part the AI is playing major role. Okay, so that is why they highlighted here. It assists in medical imaging and diagnostics and predictive analytics for disease risk and drug discovery as well. So the outcome administrative task, automatic administrative task and streamlining Okay, automate the administrative task, streamline flows, and personalize patients' score, and leading to improved outcomes and efficiency. And last one, so mention the examples, diagnosis, drug discovery, and personalized treatment. Everything also major example for the role of artificial intelligence in healthcare. So how we are using all these things? Okay, so here three sectors we are considering. One is a diagnosis part, one is a drug discovery part, another one is personalized treatment. These are all the three things are very important. So first one is a diagnosis. In earlier available medical systems, medical expert systems are only concentrated to diagnose or predict the diseases. After that, after prediction that what are all the prevention can be taken, that the early treatment can be given to the patients, that aspect only people worked. And also the earlier available medical expert system, all are analyzing the available images, okay, CT scan images or any categorical data, or all the ECG signals, everything also analyzed. Okay, just analyze the medical images, and it will give the result as whether the particular patient diseased or not. That aspect only the earlier systems are working. That is the part is available in this diagnosis. Okay. So another one is the drug discovery. So in the development of artificial intelligence, slowly the researcher use this artificial intelligence techniques for discovering the drugs also. Okay, drug discovery purpose also. AI models simulate the how millions of molecular compounds will interact with the disease targets. Okay, at the same time, drastically shortening the time it takes to identify promising candidates. Okay, so these are all the things and all happen to discover the drug discovery part. So another one is the personalized treatment part. Here AI analyzes a patient's genetic data, medical history, and lifestyle. So all the things also will be considered for starting the treatment. Okay. So here it is very important. So once we have identified the particular patient as this type of this level of disease affected, so what we have to do? What is the next? So the every patient also may have different their body nature and everything also is there. So based on their which treatment will be comfort for the particular treatment, okay, particular patient. That is very important. For example, if you are
Ganapathy sir,
considering the cancer, yes, ma'am.
Ganapathy sir,
Yes, ma'am.
there is some kind of echo or some sound which is coming up when you are speaking, sir.
Oh, echo is coming, ma'am. I closed the doors. That's why also may come. I think so. I will open the door, ma'am.
Yeah,
We'll try
yeah,
to
sir.
reduce
Yes,
that.
sir.
Echo. Okay, the personal treatment. Now it is working. Voice, ma'am. Voice is echoing or not? Now all right.
Sir, now it's okay, sir. Ganapathy sir?
Okay, ma'am.
Yeah,
Just
now
I
it's okay, sir.
open the door. Yes, ma'am.
Yeah,
I will
yes.
continue. Okay. So the personalization nowadays, the personalizations are playing major role. For example, in education sector, also the personalized learning is playing major role. Okay, so the similar kind of things what we are doing, we will identify the student nature, how much they are strong in the particular field, and what are all their status now, and identify the level of the content, and what kind of content we have to prepare and give it to them, and we have to fine tune the each and every student one by one. Okay, so that is another one part. So the personalization is nothing but, so we have to give the individual needs. Okay, whatever they are expecting, based on that, we have to provide the services. Okay, that is the personalized services. Here also the personalized treatment. So based a case to case by case, the treatment will be vary. For example, cancer affected one patient. For example, so that cancer affected the lung cancer. For example, if they are having the 2 3 treatment. Okay, so shock treatment they may give, and due to that they will reduce that affected area, and chemo they will start. Okay, so these cases and all. So if they want to give the shock treatment, any electric shock or anything that kind of, so they have to be comfort, and also they should not get any breathing problem, anything. So that kind of nature holded patient only we can give that particular start the kind of treatment. Suppose another hemo, so that is a healthy condition is required. They should not have much cold or any problem in their body. Then only it will be. It is possible. If they are in good condition, means we can apply the hemo. So these are all the three the different. When we are try to give the hemo or any other thing, they should not get uh, any seizure, these kind of things and all. We should the patient should not get. Then only we can start that. So the case by case, the different kind of treatment available. So we have to observe the particular patient history. What are all the things are available? Okay, what is the body condition? Based on that, we have to do that. That's why here what it will do, the AI analyzes the patient's genetic data. So what kind of treatment will be accommodated or can be given to the particular patient. Next, medical history. What is the medical history? Whether they will affect any other things or not. So everything they will check. Okay, so what kind of, whether it is suitable for the particular patient, like that medical history will be checked from their childhood also. It will be considered. Then only based on that tablet, for recommending the tablet also, that is medical history is very important. The physician will check all the things, and the lifestyle, and how they are living, where they are living, what kind of environment their body will accommodate. So all the things also will be considered. So by considering all these things, we have to give some treatment. Okay, so then only it is suitable. So the best treatment. So if you are leaving after identifying the disease, that is also not a good system. Okay, after identifying the level of the particular one, if you are taking some time to give the treatment, or blank treatment, or plain treatment, if you are giving common treatment, if you are giving to the patient, that is also not a worthy. Okay, so this case we have to identify that when we move to the personalized treatment, so it will give the better result. Okay, best result to the current stage. So to create the tailored treatment plans, so predicting which therapies will be most effective, and minimizing the side effects. Okay, that is also will be considered. These are all the major areas. Okay, 3 areas nowadays artificial intelligence working. So before that, so first of all, we must aware the differentiate. Okay, so what are all the difference between the artificial intelligence, generative AI, generative artificial intelligence, explainable artificial intelligence, and explainable generative AI. So these are all the basic difference. Only I am going to explain now. Okay, so just I will give the highlight the major differences between all these things, and the followed by the next slide will give small example for that, for ease of understanding these four artificial type of artificial intelligence. Okay, so this is not a type, so it is the next version of the evolution, we can say. Okay, so initial days artificial intelligence available, in later on they introduce the generative AI, explainable generative, like that it is going. Okay, so it is a evolution only. So what are all the differences between all these things, we can see now. So what is artificial intelligence? General artificial intelligence, just it is mimic the human intelligence. Okay, so machine will act as a human being. Okay, so the perform tasks requiring human like intelligence. Okay, so that is the task only done by the machine. Okay, so it is the foundational concept, very basic concept only available in this artificial intelligence. Next, we come to the generative AI part. Okay, so generative AI part here, a specific type of AI that focuses on creating new original content rather than just analyzing or categorizing the existing data. So usually with the previously I explained, okay, so based on what we can identify the disease and how we can start the treatment, everything also we did based on the past data only. So generally artificial intelligence will work based on the how much amount of input we have given or stored in the knowledge base. Based on that only it will work. Suppose if you are giving less amount of data or not worthy data, if you fail to give the worthy data into the system, means that will not perform well. Okay, that is as usual. So how much we are giving input, that much only it will work. Okay, so the past data based performance only we can get it in the normal artificial intelligence. Okay, when we come to the generative AI, here it is creating new original content. Okay, so here there is no analysis and categorization of existing data under this part. It is creating the new content. Okay, new content or suggestion or whatever we want. Okay, so obviously all the people are nowadays working using the LLMs. Okay, so so without I think the majority people, okay, 99 percentage people are started to use the LLMs for small task also. Okay, suppose if you want to know about any concept, just type it. Because of Meta AI already attached in the WhatsApp itself, whatever we want we can type it and we can get that. We can get image, PPT or content, and whatever we want we can get it. So what, how it is working, it is referring the various repositories and creating the new content based on our request, and it is providing the content. Okay, and also suppose if you are giving some solutions, so these are all the for single problem. If you are giving if you are giving 5 different solutions, and you can get the suggestion which one is best, which one is not good, or which one is suitable for this situation, whatever the analysis if you are asking, it will give. And also it will give the categorization also. So whatever we want, new content, a new idea, everything it will be given by the generative AI. Okay, so think of models that generate art or write stories. Okay, so now the creating nowadays so many tools also available, AI tools for creating the graph or pictures or whatever. Suppose if you want to discuss about categorize into one 5 content, okay, 5 different types of names or any other thing, any content. Okay, so whatever the engineering background you may be, so you can explain in Word. Okay, so you can create the content in Word and you can load it into the tool, AI tool. It will create a picture for you, and it will create 6 different kind of pictures, so that from that you can get any one best tool, best picture you can take it and use in your presentation or any other thing like that. Not only this one, so whatever the art or any, if you want to write the stories, just you can give the title, it will create the stories also. Okay, then explainable AI, this is the next version of the generative AI. We can say this is a research area that focuses on making any AI systems predictions and decisions understandable to humans. And that is very, very important. Okay, so creating content is a different task. Actually, in earlier days, also by using search engine, okay, search engine, we can give what are all the key terms if we are giving the relevant content. Automatically, it will be fetched and it will be displayed to the user. Okay, so that is under, so collecting the information from various repositories are already available. Okay, but the generative AI, it will create the by combining all these things, and it is providing us a new content to you. Okay, that is one case. Here what they are concentrating in this explainable AI, so it will provide the content in understandable manner. Okay, making any AI systems predictions and decision, whatever the decision taken, why the particular content gathered from these are all the sources, or why the particular analysis, the particular result obtained for the given data. So that explanation, okay, clearly will be given in this through this explainable AI. We can get it. So that is why they highlighted the two things: transparency and trust. Okay, so two things are very transparency, how the particular data, given data processed, or how your query processed by the system, and why the particular system given this type of content, or this quality content, or this variety of content, everything also will be explained. So that will be understood by the layman also. Okay, so next one is explainable generative AI. So now we are combining both the things also. We are going to create a new content. At the same time, that content will be explained, and why we have created that content, or why we have created that particular images, or whatever it may be. So that explanation will be given in transparency manner. So both the things will be combined in this explainable generative AI. So this is the intersection, okay, intersection of generative AI and explainable AI. So this goal is to provide explanations for the generated content, whatever the content generated. Okay, so the along with the explanation, the detailed explanation will be given to the user. Okay, that is the beauty of this explainable generative AI. So based on this much of basic introduction, you may get some idea about the differences between all these things, why we need artificial intelligence, why we need generative AI, in which situation we need explainable AI, and which situation or for what application we need explainable generative AI. Okay, what is the necessity to use the explainable generative AI? Okay, so I hope you understood all these things. Okay, next we can see the simple example, not a big example and all. So artificial intelligence, a simple AI system could be a basic rule based program that flags images. Okay, so the system going to identify the flag images. Okay, so the based on that, usually the based on the color, shape, these are all the two important features to identify the flag. Okay, so what color available in what kind of shape. So if you are giving this kind of information, automatically it will be predicted by the system the which type of flag and where from it is. Okay, so the shapes known to be associated with the condition, so the condition will be given. So if the size is this much, or color, these are all the color. Okay, these are all the shape. Like that, if you are giving if you are creating some rule and feeding to the system, so whatever the flag image if you are loading, automatically it will predict and declare the result. Okay, that is a normal artificial intelligence will do. The next example for generative AI case. Okay, so here a generative AI model like a generative adversarial network, GAN, could be trained on thousands of healthy and unhealthy skin images. Okay, so skin images we are loading into the GAN. Okay, and it could then generate new synthetic images of various skin conditions. Okay, so it will create the new images. Okay, synthetic images will be created by considering the various skin conditions. Okay, so whatever the healthy condition, unhealthy skins. So unhealthy skins may have different conditions. Okay, conditions of disease affected. Okay, skin may be given as an input to the system. Okay, so by using this, it will categorize and it will perform the synthesis. Okay, and it will create a new images. Okay, based on the given unhealthy and healthy. Apart from the combination of these things also, okay, various images will be created, skin images will be created, and all the images can be used for training purpose. Okay, training new doctors and for use in medical textbooks also. It creates something new from the scratch. Okay, so in earlier days, so just you compare this artificial intelligence example and generative AI example. Artificial intelligence example, what are all the conditions we have given, what are all the images we are given, that images what it is, that only it will tell. Okay, so what is the connection between this particular color or shape. Okay, what it will be, that only it will tell. Okay, so available information will be analyzed and checked with the pattern, available pattern, and it will tell the result. generative AI, so we are giving the unhealthy and healthy images, we are giving various thousands of images we are giving. It is generating the new images. Okay, so creating the new images by using the various conditions of the skills. So this is the beauty. So this kind of, if you are creating so many images in this generative AI means, automatically it will give more information. Okay, so that doctors will get more information about the various skin conditions and the different skin images, and so that will be helpful for creating or understanding the disease level or any other thing, and understand about the skin everything also. Okay, this is the beauty of this generative AI. Next one is explainable AI. Okay, so explainable AI, this case, okay, model would not just provide a diagnosis, but would also highlight the specific areas of the image that led to its conclusion. It might outline a mole and show a graph. Okay, you please listen this part. The detailing how the mole's irregular border and color variation contributed to a high risk score. So how the particular image, okay, got high risk score. So that detailing, that explanation will be given. So the previous, the generative AI, what it does, so it creates a new images according to the various available conditions or skin levels, everything. It creates a various images. But this explainable AI, it is providing the detailing. Okay, so detailed information it is providing for the things. Okay, that is the explainable AI. Next one is the explainable generative AI. This case, we can take one small example here. The generative AI system would combine these. It would generate a new synthetic image of a skin condition. Okay, so based on the previous generative AI, what creates the new images, a synthetic image of a skin, okay, condition, and then simultaneously provide a detailed explanation. It is the combination of the generative AI and the explainable AI, the combination of these things, these two. Okay, so it will create a new images also, healthy, unhealthy images. Okay, it will create new images with a different condition or color or any other thing, along with the explanation. Okay, this is the beauty of this explainable generative AI. For instance, it could generate an image of a melanoma and also include a report, okay, stating the image was generated to illustrate an irregular asymmetric model. Okay, for example, the asymmetry score is 0.9 with multiple colors. Okay, the variation score may be 0.8 and common features of melanoma. Okay, it is not just creating, it's explaining its creative process, how these are all the values given, okay, for the particular images. That explanation also will be available in these things. So I given detailed explanation about what is AI, what is generative AI, what is explainable AI, what is explainable generative AI, and how these all the four evolutions are applying in medical field. Okay, healthcare field also I explained with the small example. Okay, so I hope understood. Okay, why we need this explainable generative AI right now. Okay, so for initiating the personalized treatment to the patients perfectly. Okay, now the rise of generative AI. Now the generative AI, how it is developing. AI and its capabilities creating text, images, data. That is the major thing. Here, generative AI creates a novel human-like content by learning from vast data set. Okay, and text, images, data. These are all the three things are very important. Okay, so it will cover almost all emerging applications. Okay, so text models like GPT-4 can write articles, code, and stories, everything. So nowadays, the already I discussed about LLMs. So many LLMs available, ChatGPT, and Gemini AI tool. Okay. Claudia available. Okay. So many things available. So you can, all the tools and all LLMs are what it is doing, it is used to write a new content. Okay, generating the content for the based on the query, whatever the query we are giving, whatever the request we are giving, it will give. Code also it is creating. Okay, suppose if you are not aware about the particular solution for the particular problem, so you can give the problem, so it will give the source code and the problem. Not only the, suppose if you want to get the answer for the any machine learning problem, you can give the scenario and ask the LLM to apply any one classifier and generate the answer, so it will give that. If you load the data set and mention the particular algorithm, and if you need the detailed explanation or workflow, it will create and give it to you. So this kind of word, okay, so the predicting the most probable sequence of words, okay, so that is available. The normal thing also, if you are if you loaded, okay, in our mail content also, what it is doing, what sentence you are starting, it will be completed. The next word it is suggesting. So based on the sequence, what is the content already you written in the particular box, based on that it will suggest the possibility. So what are all the probability for possibility available, it will suggest and we can choose and create it. The images, okay, next tools like DALI and Midjourney, okay, can generate unique visuals. Okay, so different kind of images also can be created. Okay, so many tools as of now available, all are working based on that generative AI only. Okay, but the purpose they are differentiating. Okay, so the different purpose they have created different images. Okay, from realistic scenes to imaginative art based on the text prompt. Okay, so the different kind of new unique visuals, okay, it will generate, it will create the images. Okay, next data. Generative AI can create a synthetic data sets also. Already in example we have seen that. Okay, synthetic skin images it will create. Okay, by considering the various types of skins or everything, so it will create a data that. Okay, so images. So the same thing, data also will be generated. You can create some dummy data set or format you can give. That format you no need to create manually for that or anything. Okay, so you can ask the LLM to create or generate AI to create a different kind of data set. It will generate. Just you can give the features, mention the features. These are all the features. Okay, can you create one data set for that? So it will create and give it to you. Okay, and for training and other AI models, addressing the privacy concerns and the data scarcity also. So this technology outcomes creative and analytical tasks. Okay, pushing the boundaries of what machines can produce. Okay, so these are all the three things are very important and major tasks done by the generative AI. So the next one is the highlight the potential of generative AI in healthcare. Okay, going beyond traditional analytical AI. Okay, so the generative AI's potential in healthcare extends beyond the predictive and analytical capabilities of traditional AI by creating new content and data. So, how we can perform the predictive analysis or analytics and all? Okay, that is based on the content, what it creates. Okay, so how much effective data or content. So that's why I told that it will create the new skin images by giving the variety. What are all the varieties you are mentioning? What are all the different kind of sample data? If you sample images you have given, those things will be considered. By considering that what are all the variety of images possible to create, it will create and give it to you as a data, right? So while traditional AI analyzes existing data for diagnostics or risk prediction, generative AI can simulate new molecules for drug discovery. Okay, so it will create a new molecules for identifying the drug also. Okay, the dramatically accelerating the R&D process. It can also generate synthetic medical images that so many examples I explained here without compromising the patient privacy also. Okay, so the patient privacy will not be affected. Okay, so if you are still doing any medical related project, means for collecting the data set is very important. Live data set creation is very important. So for initiating our research work is a very big task in the earlier days. So as of now, we can give the some sample data to the LM or generative AI. Okay, so you can generate your own data with the help of the generative AI, different kind of images that can be used. Okay, so usually the leaf disease detection, okay, system. So one of my student did in my previous institute. So that time she told us, sir, I collected only 10 images only, or 15 only possible, like that. Even PhD also the people collected, okay, by taking more time and by travel the so many places, various places, and identifying that, and collected only 50 images maximum, like that. So these kind of things and all can be synthesized and can generate the new images also. So the medical cases also, suppose through 2 3 patients or a very less number of patient detail, we can get it from the doctor, and we can create the mimic the new things also. At the same time, that is not belongs to any patient and all. So it is a synthetic data, medical data, images. Okay, so that is no issue. At the same time, it can be used for prediction process also. That combination also acceptable and considerable also. Okay, we don't know what type of different kind of diseases will transforming from the basic disease and all. Okay, so that basis we can easily do that. It can craft the personalized patient facing content, okay, such as tailored educational materials and treatment plans, or assist with the administrative task by summarizing clinical notes and drafting correspondence. And this shift from analyzing the creating content unlocks, okay, new avenues for innovation and efficiency. That is also very important. Okay, so that the creation is playing major role in any process. Okay, wherever we are going, what kind of research work we are doing. Okay, so already I told you that basically the AI starts with the available data. How much effective data, how much volume of good quality content you are giving. Based on that only, it will generative AI also will create the new content based on the available information. So it will create a new version. If you are giving the more variety of samples already, so it will create so many things and all. Already we knows that how to accumulate the things from the available, right? So next one is the healthcare decision support systems. So healthcare DSS. Okay, so healthcare decision support system, DSS. Okay, shortly called DSS. So here the tools that provide clinicians with evidence-based patient-specific information at the point of care. Okay, so here the three things are very important. Evidence-based, patient-specific information. Evidence-based, patient-specific means, so what are all the input given? So that input will be analyzed and come to the conclusion. So anyone decision will be taken. So next, analyzing the data from sources. So that already we knows that what are all the information we are giving, that will be analyzed and we will take one decision. Okay. So they offer alerts, reminders, and recommendations to assist in clinical decision making. For example, one diabetic patient is there, so he is in under the diabetic treatment. Okay, this is a treatment under a particular physician. So what it will show that in what time they have to take a meal, what time they have to take a tablet. So everything also we can fix as a alarm. We can automate the things and okay, reminders can be given in the form of SMS or alert message or sound or anything we can create. And also nowadays the advanced system available, what type of question, what type of medicine or what level of medicine need to be taken. That is also available. So these are and all the small clinical decision making process. So this decision no need to take after meeting the no need to take these kind of decisions by the physicians. Okay, so every time we cannot frequently meet the doctors and all. Okay, so the regularly we can monitor our body health, and our system will measure or monitor that our glucose level, all the things. So for example, I am talking about this diabetic, the different various diseases. So they may monitor different things. Okay, that will be automatically that will be observed based on the dosage. Okay, based on the level current situation, it will recommend the dosage. So different dosages, a tablet or a treatment will be suggested to the patients. So that is also available. So there are very simple example I can say. Okay, once nowadays the many people are wearing the smartwatch. Okay, how many steps they want to walk. Okay, how many if their body need water. Okay, so water that alarm will okay flash in that watch itself. So, what is the reason? So, your body is not having sufficient water level, so you have to drink the water like that. Okay, so these are all the sensor based automation. Okay, the specific sensor based automation and alarm system designed in the particular watch. Okay, so when we talk about the personalized treatment to the particular patient, so their history can be stored and their conditions will be set by the physician input. Okay, physician. Okay, then automatically it can be used by the patient for regulating their treatment. So their importance for clinicals, okay, clinicians in humans. Okay, DSS help enhance the patient's safety. Okay, safety by flagging potential drug interactions, allergies, or error or medication dosing. So we can enrich the patient safety. Okay, so through the with the help of the decision support system. So simple. In practically we are having the sugar level checking. Okay, so how much we have a sugar? If it is high, okay, for example, 600 plus or 500 plus like that, if it is showing, so we can use the insulation. Okay, insulin. Okay, we can use the injection. Okay. So injection also this much level already doctor suggested, so we can do that. So suppose if it is very less level, so tablet is enough. We can take a tablet also. Okay, like that. Okay, so this is the practically available things I am telling. But this kind of explainable AI incorporated decision support system will give the advanced recommendation. Okay, that is a different for me for ease of understanding. Practically, what we are as of now using the devices that I am telling. So similarly, it will support for the advanced and personalized treatment and medicine will be suggested by the explainable AI based decision support system. So they also improve the care quality. Okay, so automatically it will improve the treatment care also automatically improve, and DSS aid in reducing the diagnostic errors, okay, by providing a differential diagnosis based on a patient's symptoms and lab result. So this allows the clinicians to make more informed, efficient, and safer decisions. Okay, ultimately leading to better patients' outcomes. Okay. Next, healthcare decision support systems. How AI can enhance the capabilities of DSS. Okay, so in what are all the ways the performance of DSS can be enriched? Okay, so AI fundamentally transforms DSS from static rule-based systems into dynamic. So already I told you that the rules will be created, okay, by the expert. For example, medical expert system means a physician will give the rules. Okay, so that will be converted into the generate the new rules. Okay, by using their instruction, and it will be fed into the system. The system, the whenever the different kind of situation will come, it will take a decision. Okay, dynamically it will take a decision with the help of the rule what we have included in the system. Okay, next learning platforms. Okay, so it will learn the current situation or available information. It will be learned and identify the pattern. Based on that, it will work. So the basic DSS will show that, okay, what are all the rules available, what kind of dynamic decision can be taken, what are all the input given, and what are all the learning patterns identified by the DSS. Okay, by leveraging the machine learning AI powered with the help of the machine learning algorithm, and it will analyze the massive or unstructured data sets. Okay, so including medical notes, images, and genomic data, everything. Next, predictive analytics. Okay, prediction, how we can do that is also rule based only, we can do that, right? So this is the pattern. So suppose the five features available, glucose level this much, and after meal this much, or the sugar level, okay, glucose level, and blood pressure, and all the things. Okay, so some the relevant features will be considered based on that. This is the pattern available, this is the threshold, this above the threshold means we have to take one decision, below that threshold means one decision, that already available, fixed. Okay, rules are available. Based on that, it will be predicted whether the particular patient have level 1, level 2, level 3, okay, what level of disease, okay, affected, that will be identified, enabling the early disease risk identification, that predicting sepsis hours before the symptoms appear, before showing the symptoms to the human being. Also, we can easily analyze, by analyzing their our observing the body condition. Easily we can predict that this kind of disease you may get it, or the symptom will appear after this month or this much days, like that. We can easily predict that with the help of the DSS. So personalized treatment plans tailored to a patient's unique profile according to the, by analyzing the patient unique profile, so we can suggest the unique treatment or personalized treatment plans we can give with the help of the DSS. Okay, and another one role, AI enhances the system's ability to provide contextual real-time insights and reducing alert fatigue, and ensuring the clinicians receive only the most relevant actionable recommendations. Okay, so this evolution empowers clinicians with a more powerful, intelligent, proactive assistant, leading to better patient outcomes. Okay, so this normally AI based the DSS. Okay, it will predict the diseases in advance, and also it is a transformly. We can see the static and all all the rules and regulations, whatever we feed it, and it will identify the learning patterns with the help of the machine learning algorithm, and also it is capable of analyzing the available input and whatever the data we are giving, whether it may be the numbers or images, it will be analyzed by the system, and we can predict the diseases in earlier. Okay, the without observing or getting the symptoms, also we can in advance we can predict the diseases. Then personalized treatment will be start, and contextual and real-time insights also will be provided with the help of the DSS. The critical need for explainability. Okay, so they introduce the concept of explainable AI. So where we need explanation. So before that, in the previous up to this slide, okay, the decision support system, how it is working, where the artificial intelligence, okay, using playing the role, and generative AI, how they are using, okay, how it is creating the data and predicting, that aspect we have discussed it. Now we come to that explainability. Why we need explanation for initiating any treatment or whatever the decision support system providing the results, okay, over the results of DSS. So now explainable AI is a field of research focused on making AI models decisions transparent and understandable to humans. Okay, understandable to human. So already I explained, I given clear information about the explainable AI, what it is. Okay, how, what are all the transparent things we are getting. So how by showing the available or creating or generating things, and okay, transparently, what are all the content available or data available, images available, that we can, okay, for for by the human being can understand, okay, by showing that. So simple example, I will tell you that. Okay, for example, one figure is there. In figure, the parts of the figures will be available. Okay, human body. Okay, figure in very in schooling days we have seen. So each and every parts also the picture will be given and every parts also mentioned in and explained. So in the picture, by seeing the picture, so these are all the parts available in the particular area. Like that we can understand. After that, we'll explain. Okay, the textbooks explaining all the parts, what it will do, what is the flow, like that it will explain. The same thing here applicable for the result. Okay, so suppose you're the one patient, one we are giving one patient image. That image will be analyzed by the explainer by using explainable AI. It is analyzed and give the result. Yes, the particular image is a diseased image, like that. It is giving the input. Sorry, output. Not only that output, how it is diseased, what is the original, what is the this is a clear image. Okay, this is the normal image. Normal page should be like this. Okay, this area of image is in color is red. Okay, or any one color. This is color is shading or this one. That information will be given. That is why it is affected this part of the body, and also and then this name is this one, and these are all the different colors available. If you are facing red color means this level, and brown color means this color, like that. Blue means like that. Okay, the detailed explanation will be given by showing the available or generated, okay, or given images, so easily the people can understand. Okay, so what is the problem, why we have affected, what it should be, like that easily we can say, understand the scenario. That is the task done by the explainable AI. Now XAI, okay, explainable AI aims to shed light on their reasoning. Here they are using one word. Okay, especially deep learning networks operate as block boxes. Okay, so I hope you may aware about that block box and white box. Okay, so block box is a internal, okay, internal logic, internal issues. Okay, so the explainable AI have a block box. So what it is, it will explain internally what is the issue over there in that part itself. It will explain. That's why. Okay, so the internal process will be explained clearly in this explainable AI part. That is why block boxes, okay, will be operated over there. Next, this is crucial in high stakes. Okay, high stakes domains where trust and accountability are paramount. Okay, both are very important. Already I told you that, okay, transparency and trust both are very important in this explainable AI part. Okay, the transparency, we need to give the proof. This is what, this is this result. Okay, you have given 4 plus 3, that's why 7. If you give 5 plus 2, then 7. 5 plus 4, 9. Like that. Okay, the explicitly, okay, transparently it is showing the proof and the explanation. Next, XAI techniques can provide the insights into which data features most influence the prediction process. That is also it will do. That's why I told you. Okay, in that whole image, okay, the particular part of the image color should be like this. That is the normal color. So your input image has this type of color or this dark color or blurred color, like that. Okay, it will give the detailed information. Okay, for the result. Next, emphasize why explainability is paramount in high stakes domains like healthcare. Explainability is paramount, okay, in healthcare because high stakes domain where AI's domain, sorry, decision can directly impact human health and lives. Next, another one important point, understand and reasoning behind a diagnosis. Okay. So the lack of transparency poses several critical risks. Okay, here three things are mentioned in this presentation in this slide: the trust, accountability, and bias detection. So trust between clinician, other physicians, and AI system. Okay, so the both the same. The doctors need to give the proper information, okay, information and input, okay, to the system. Based on that, the system will work it out. Okay, so it will create an image or anything. The decision can be taken according to the doctor's input only. Doctors are unlikely to accept or act on a recommendation they cannot validate. So already some experts, doctors given some rules and regulation to predict the particular diseases, everything, and already feed it into the system. The other physicians, okay, so the less experienced physicians who need to trust the system. What the system recommended, okay, that he need to accept that. Okay, so at the same time, they cannot validate, okay, apart from their capability and all. That is why they mentioned they cannot validate, especially if it is conflicts with their own clinical judgment. So where we are using the explainable AI over the decision support system, it will give the clear explanation about the for the particular decision. So whatever the decision it will provide or result it will provide, it will give the clear judgment. Okay, but that particular justification given based on the input given by the particular um, disease expert who is expert in the world, based on their input only, it is providing to all the doctors. So whoever using the particular decision support system, they cannot validate and all. Okay, how it is, how much it is, the judgment, justification and all. We cannot see that. The second one, it creates a serious accountability problem. Okay, so once the particular system, for example, AI system makes an error, okay, that harms a patient. Sure. So it's unclear who is responsible. So this case we have the accountability. So suppose the system is properly working and correct decision will be taken, and early we have started the treatment and personalized treatment plan and continuing, and the patient curing from that particular disease, well, good. The particular doctor also will get the credit, and DSS also, okay, who developed the particular system, those people also will get the credit. Suppose if any one mismatch happen, so doctor will blame that. The controversial things will go there. That is the accountability problem. That is also will come into the picture. Next, explainability is essential for bias detection. Bias detection. So here, if an AI model trained on non-diverse data, okay, perpetuates health disparities by providing biased recommendations for certain demographic, okay, groups. Explainable AI is the only way to uncover the rectify this. Okay, bias detection also very important here. Next, we can come to the explainable AI in healthcare. Okay, so up to here, need for this explainable AI we have seen. Next, explainable AI in healthcare, we can bit already I explained this point and all. Okay, so how it is important, how it is working, transparency and trust, and block box it is available. Oh, sorry for the inconvenience. Okay, so 2 minutes internet lost. Okay, so what is explainable AI in healthcare? Okay, so already we have discussed the transparency and trust are playing major role here, and block box it is available. Okay, so how it is carefully addressing the issues. Okay, to the about the particular problem or about the particular image or problem any other things. Okay, now, why it is crucial? Okay, so diagnosis and the treatment plans. So this is also we have discussed in detail with the various examples. And clinic says physicians, okay, need to understand how an AI reaches its conclusion to trust. Okay, so trust accountability also we discussed in the previous slide. Okay, who will take responsible for that? The physician physician will get the explanation. Okay, for getting the so suppose that without incorporating the explainable AI decision support system DSS means okay the doctor may not get it what it is. Okay, so otherwise suppose the particular explainable AI incorporated DSS is providing detailed justification or explanation for the particular decision. So the doctor should accept. But the all users may not believe or faith on that over their particular system. And all. Some people may get the controversial statements or points also. Okay, so there if their trust level is reducing or decreasing, then that is the problem. There, the crucial. Okay, that is the crucial. So, and that is one case. Another one case, the physicians can take one decision. That decision can be validated through the explainable AI based DSS. Okay, so the decision, yes, for this image, I am guessing like this. So, what is your opinion like that? That image can be given as input to the DSS, explainable AI based DSS. That will give the detailed information. So, what he assumed, what based he taken on that decision, that can be cross validated with the DSS, right? Next, explainable AI in healthcare. This aspect, the role of explainable AI in healthcare supportation support system and all. Improving transparency, enhancing trust and adoption, and facilitating regulatory compliance. Okay, so improving transparency. Transparency automatically improved because of here task is to make understand by the human being what it is, what solution it is providing. That is a major task already we have discussed, right? So the transparency automatically increased in this explainable AI because of it is providing the detailed explanation for the decision. Next, enhancing the trust and adoption. So without explanation, there is a question mark will come. So where is the trust like that? How much what is the volume of trust like that? So adoption also, the people will think to use the particular decision support system. Okay, when we are giving the detailed explanation for the each and every steps also, so automatically the trust will be enriched and adoption also will be automatically number will be increased in the society. So that is why enhancing that trust and adoption it's mentioning. Next, facilitating regulatory compliance. Here, healthcare is highly regulated. XA, explainable AI, helps meet regulatory standards, okay, by making AI system variable and understandable. So whether it is understandable or not, okay, verification that aspect also will be checked over there. Next key concept, what are all the key concepts available in this explainable AI in healthcare aspect? Okay, so transparency and transparency we understand on AI systems and internal processes. So this point you can note down that transparency is nothing but understand on AI systems internal process, how it transforms inputs to output, how it is okay transforming from input, given input to output. That detailed explanation will be given. Interpretability, here the degree to which a human can understand. Okay, so that the degree of understand also, okay, question mark, the cause of decision made by an AI. It helps healthcare provides explain AI based decisions to the patients. Next one is a trustworthiness based on its transparency, accuracy, explainability, everything. The trustworthiness automatically will be enriched. Trust is enriched in the society. Trust is essential for the adoption of AI in healthcare. Okay, so if we are believing the decision support system, then only we will adopt the particular system in our treatment purpose or whatever it may be. Next, explainable AI in healthcare aspect, the explainable AI techniques and applications. So what are all the techniques? Okay, so intrinsically interpretable models. Okay, here these models are simple enough for humans to understand without extra explanations. Okay, without extra explanation. Usually, the layman may not get it if we get it the explanation, medical explanation with the medical terms and all. Okay, so that time and all we need some extra explanation. Okay, so for them, the system need to give the detailed explanation what like that and all. Okay, example, decision trees and rule based systems are used for tasks like disease diagnosis based on patient symptoms and test results and all. So disease diagnosis, I hope I don't know how many of you are having how many of you are from computer science background, but a decision tree, I will tell you in one line. Okay, the decision tree is nothing but it is working based on the condition. Okay, so if you are willing to do this one, yes means will go one side, no means another one side. Yes means so will additional question will come. If you are comfortable with that, then we'll go that side like that. The tree will be constructed. That is the decision tree. There in between the each and every decision also we have a condition, separate conditions. So that is why they mentioned the decision trees and rule based systems. Okay, so by based on this only the decision disease diagnosis is working. Okay, the prediction systems are working based on that only. The post hoc explanations, techniques applied after complex model has made a decision. So post hoc explanation, this is next level. So how it is working, what are all the conditions incorporated, rules available, okay, over the how many rules, the suitable rules fired over the input of the patient. Okay, so inputs, okay, patient details or patient symptoms, okay, that will be giving us an input. Okay, sorry, output. So post hoc explanation here, the techniques applied after a complex model. Okay, one model take a decision. Okay, already taken decision and it provides. Okay, so that will be explained how the particular decision arrived. So that information will be explained in this post hoc explanations. So here the local interpretable model. Agnostic explanations. Okay, so here the explains individual predictions for black box models by creating a simple and local approximation. So already I explained about the black box. Black box, what it will do, it is containing the reason for making the decision, for the particular decision. Why I made this decision. So if you need, you can refer the block box. You can get the detail about for the particular decision. That is the things, right? So next is shape. Okay, so SHAP. So shapely additive explanations. Here assigns an importance value to each feature to explain its contribution to a prediction. Okay, so the visual explanation is encouraged in this particular shape. Okay, so here use visualization to make a complex model, behavior, understandable, everything. Okay, so it will show the particular thing. The best example they taken as a MRI image, a tumor in an MRI. Okay, so that an AI model focused on when making a diagnosis. Okay, so the particular region of the medical image affected the particular tumor. Tumor affected this area in that particular MRI image. Like that, visually it will identify the place and it will give the justification what the supposed to the original or the healthy image how it should be, and diseased image what color change, like that. The all the explanation will be given visually, will be explained in this shape. Okay. Next, challenges of implementing XAI, explainable AI in healthcare. So still we have discussed what is explainable AI, how we can, why we need to incorporate this, what is the usage, everything we discussed. Now we came to that, what are all the challenges? Okay, so challenges that also we need to discuss. The general challenges about the DSS already we have discussed. Okay, so there we need to get the proper transparency, trust, and accountability, all the aspect we have discussed. Now, especially this explainable AI in healthcare part, if you are implementing, what are all the implementation issues we will face? That aspect we can see, discuss here. So, accuracy versus explainability trade-off. In this part, highly accurate but difficult to explain. That is one. And achieve the same level of performance. Okay, so suppose the in the same decision support system may not perform uniformly over the different images and all images or input whatever we are giving. Okay, so that is we need to we may not identify the exact reason for that and all. Okay, so because of the creation, the image we have generated so many images that that minute part may be matched with our input, or these are all the things and all will the issue here. Next, complexity of medical data, noisy and unstructured. That is healthcare data. Obviously, the noisy data and unstructured data we have, the making it difficult for AI models to provide the clear explanations. Okay, so that cases the model will not provide the clear explanation also because of that color is suppose if you are taking one image and if you are loading one medical image, that medical image is good quality colored image means immediately the model will identify the predict the result and will give the detailed explanation for that and the color quality also the quality of the color is not good. What it will be? So the entire the decision also may vary, change, na? Because of the by observing that particular color, this color, this is not a pure red. So suppose that the color image is not showing the pure red. It is the mild red. It is showing. So that decision is different. So that things and all problem. Next, ethical and legal concerns. So while XAI, explainable AI helps with the transparency, it does not fully address questions of legal responsibility if an AI system makes an error. Okay, so that is another one ethical issues are there. Okay, system error also will come whenever we are showing the transparency and controversial already we have discussed over there. Okay, in the previous slides, user acceptance may resist adopting systems. Okay, so with the clear explanations may be enough good enough for some people physicians. Some physicians may not accept that explanation. This is not clear, it is vague explanation, so I cannot accept this result like that. Some people so accept. These are all the challenges, major challenges we will face. Okay, next Gen AI in healthcare part. Okay, so generative AI part. So explainable AI in healthcare we have discussed in detail, and generative AI in healthcare aspect. Okay, so created. This is also already we have discussed in the previous slides itself. So for what purpose we need generative AI? So it will mimic or it will create a new images, a data, content that only here also we are talking, and generate new unique images will be address the data privacy concerns and improve the performance. And generative AI for medical image analysis detect the anomalies and improve the diagnostic accuracy. Okay, because of diagnostic, how they are claiming this one. Okay, this helps to improve the diagnostic accuracy. Diagnostic accuracy, how it will improve the which system not use the generative AI. So okay, that decision and the system incorporated the generative AI. So how this difference means? So the diagnostic here the generative AI already I told you that according to the variety of skin color and skin types or variety, it will generate so many skin images apart from the given input. So with the help of the generative AI, it will create all the possible images. Okay, and it will be considered for making the decision also. So the decision will be well accurate. Okay, very good accuracy we can get it. So suppose if we are not incorporating the generative AI, means what will happen? Whatever the images we have given in explainable AI, I told you that the issue on challenge I told that acceptability. So acceptability is a challenging task because of what kind of quality image we are giving, what kind of quality input we are giving. The quality of the input is not up to the mark. The decision may be wrong or different also. Okay, so the same kind of issue will happen in other AI normal AI based DSS. Okay, without incorporating the generative AI means that issue may come. Okay, that even if you are incorporating the explainable AI also, whatever the images we are giving based on the color appearance only, it will give the result. So that is the one big question. Okay, so but when if we use the generative AI, automatically those things and all will be sorted out because of it will create the possible all the images automatically it will generate, and it will use the conditions given by the physicians, okay, expert physician. So then it will take a very good decision. Okay. Now the text generation aspect, LLMs already we knows that. Okay, for what purpose the generative AI means automatically it will create the records. Okay, so patient record also no need to collect the fully all the possible also. Okay, so the some varieties you can give, and from some symptoms if you mentioned it will generate the data. Just you can mention the possible features, so it will create the data set also, medical data set. You no need to do that. That is why the consultation electronic health records, okay, lab results, and reducing the administrative burden on clinics. Okay, so that can create the personalized and easy to understand the patient education materials as well. So next, for drug discovery and development aspect, create a novel drug candidates. Okay, so Gen AI will create the new drug candidates with the different by learning the from vast data set of existing molecules. So what are all the available information? So all the things will be analyzed and create a new drug candidates also. So based on the real observation, we may get some drug candidate. These are all the symptoms, these are all the things. Apart from that, when we use the generative AI, it will use all the properties and available data set, everything. It will create a new type of drug candidates as well. Deep learning and reinforcement learning to generate new molecular structures. Okay, so this generative AI incorporated, these are all the reinforcement learning and the deep learning techniques. Already you are aware about the reinforcement learning. Reinforcement learning, it is a feedback model. Okay, so again and again it will be refined and get the good result. Simultaneously, the generative AI models predict the crucial properties like efficacy, toxicity, and metabolism. So these are all the things and are costly in lab synthesis. Okay, so this is the way drug discovery and development part. It is used to, okay, it can rapidly identify the disease targets. That is also possible. And generative AI then designs novel molecular structure. This point already we have discussed in the previous slide. And another one, the personalized medicine already we discussed. Okay, personalized treatment. Okay, treatment can be given. So generative AI creates the personalized treatment plans by integrating and analyzing the diverse patient data, including electronic health records, genetic information, and real-time wearable device data. So electronic health records already we have seen. Genetic information will be referred for the possible available genetic data will be referred for analyzing the particular individual patient data. That are and all already we have discussed. The another one is real-time wearable device data. That is why the simple example I told, watch I told, and other the diabetic prediction system. No? So that is the small device on a kit, sugar kit. So that is these things and all small, so many devices available. So whatever the devices, wearable devices, through the wearable devices, we are getting the input that will be analyzed, and we will get the proper explanation from the Gen AI based DSS. Okay, Gen AI, and it will create various data also, real-time data also it will be created. Okay, based on the available information. It identifies unique patterns and correlations. Okay, so automatically it will generate new patterns. Okay, from the available. How many values you are giving? So based on, for example, three. How many, what are all the possible combination it will create? Okay, for example, three symptoms if you are telling, so 2 power 3, so 8 different combinations also possible, and generate a customized plan with the recommendation for therapies, drug dosages, and lifestyle changes, everything also possible. Then this approach moves healthcare from one size fits all model to the highly tailored one. Okay, the personalized medicine aspect, the genomic data, medical history, lifestyle, wearable device, everything. And medical dialogue and chatbot. Yes, this is another one important point. Nowadays in hospitals, almost the very big hospitals, okay, and not only hospitals, the educational institutions, some organization and recruitment companies, these all the people, they incorporated the chatbot in their website itself. Okay, so once if you visit the particular website, immediately the chatbot will open and how can I help you for you? Like that, it will ask. Okay, uh, so whatever the query if you are asking, so it will answer. Okay, we can fix the appointment also. What are all the admission related or any job related, whatever the query we are posting, immediately we will get the result. Okay, this is the dialogue, dialogue. The same that is why how it is working. It is already fixed one only. The generative AI already the possible questions and answer everything. It is available. Whatever the questions we are asking, so it will map with that repository and it will provide the answer to the particular. At the same time, real time, what is the database, the particular doctor, how many patient already booked in the particular duration, whether it is available or not, that automatically it will check the database and it will give the result for that, right? So this is the appointment related or dialogue, or suppose if I am having the small any frequent specialized physicians may fix their own website, their own page. They will fix some incorporate some chatbot related to for answering their own patient. Okay, so there whoever continuously taking treatment under a particular physician, that physician aware about their patients conditions, symptoms, what are all the things may be faced, for that what is the answer, everything also they can feed into the chatbot. Okay, and the chatbot can be appended with their page whenever they visit their patient will visit their particular doctor page, so they can get the automatically they can get the suggestion from the doctor. Okay, so this is the medical dialogue and the chatbot. This can be done through the generative AI only. The challenges of black box AI, already we discuss about the black box. Okay, how the particular decision can be made, what is the reason behind that, that will be explained in that black box only. So the here understanding the black box models. Okay, so that is difficult to interpret the complex deep learning models arrive at a decision. Okay, and that is one challenge. Another one challenge, limitation in trust and adaptation. That is always the questionable here, and the risk of bias and errors. Okay, errors and bias may happen in that. The challenge in accountability and the responsibility. Accountability is a big issue when we are using the this kind of explainable AI based explainable generative AI based DSS and regulatory hurdles also. The regular problems, what are all the problems, create effective policies and standards and all. Okay, importance of explainability AI, building trust and confidence. That is very important. We have to build explainable, okay, generative AI based DSS if you are developing. So we have to create the at the same time. Okay, understand and validate the AI recommendations. So what are all the suggestions we have feeded and what are all the combinations it is creating. Okay, so whether all the explanations are correct or not for the particular decision, everything we have to cross validate, and it should be understood by the human users. Okay, next, enhancing the clinical decision
Ganapathy, sir.
making. Yes, ma'am.
Sir, there are certain questions which has been posted in the Teams chat, which has
Yes,
been
yes,
asked
ma'am.
by
Yes, ma'am.
the
Yes, ma'am.
participants.
Yes, ma'am. 2, 3 slide only available. Shall I complete or we can answer the query?
Yes, sir. Certain set of questions which continuously being posted, so that is what I'm
Okay,
just
okay.
interrupting you, sir.
Ma'am? Almost
Yes,
completed. Okay, time
yes,
also
sir.
over. So you can ask me. What
Yes, sir.
question?
There are certain, which is already posted in your Teams chat, sir.
Team
where the
chats.
audience are asking. Yes, the audience have posted in the YouTube. We have just put up on the MS chats.
Yes, ma'am. I will check the chat bot. Okay. I will start from the first question, ma'am. Arvind Rajput sir. Okay. Can we create color image synthetic data? Also, limited color image data set. Can we increase our data set using any model or method? What is synthetic data set and other? Okay, so sir, one doubt, sir. I had 1,000 data sample ECG signal. Sir, I had completed my PhD with this past 3 years. Whether this sample can I give to generative AI? Yes, it is possible. Already I told you that. So generative AI also working based on the people only. Okay, so we have to give some input, we have to give some combination, we have to give some certain conditions, rules and regulation only. Okay, so the image creation, for example, the so many tools are available for creating the graph, image, or everything. Okay, so that is so many tools available. But this case for creating the synthetic data set by using the minimum level of data whatever you are having, but that should be programmed. Okay, that should be programmed, then only it will create that. Okay, otherwise the by default any synthetic data creation tools available or not, that we have to search, and we can use the particular tool. How we are using the chat gpt and Claude, Gemini AI and all like that. This is not simply it is not working directly and all. Okay, so already the team worked over there and incorporated all the things over there. Then only based on that only it is working. The team is continuously working. The same thing, this image data creation also, with the help of the generative AI concept, we can create the many images, the combinations of images we can create and incorporate into our own system for creating the image also. Okay, there is no, as per my knowledge, I didn't use that particular generative AI tools for creating the synthetic data, but the possibility is there. The usage of generative AI I explained, and that can be used here. Okay, so I am not sure about the market status over the image. My area is that data and intrusion detection part only I am working. Image files, few image related works recently I am doing with my along with my students. But this case, it is a new topic, generative AI and explainable AI part and all. But whatever the feedback, everything we have discussed based on that. Okay, so we can create the data, but the similar kind of system, anything may be available. Okay, must be available. Then only that only can be used for generating the data. And another one question, feedback from doctors will be considered. Yes, definitely we have to consider the doctors' feedback. Based on that only we have to create the make the system. Actually, whatever the medical paper we are writing, medical related research paper if we are writing, we should collaborate with the medical doctor. Any medical doctor, what where we are working over there, na? What about the particular disease. Okay, disease expert, any physician must be collaborate with our research work, then only it is acceptable and accountable also. Okay, otherwise without medical doctor, general information, website information, these things and all if you are considering, that may not be considered by the reviewer or acceptable. So we should get the doctor advice. Next, how explainable AI used in image disease prediction. Explainable AI, not only explainable image disease prediction, in all leaf disease prediction or whatever it may be, we can design. Okay, so every people are thinking that is there any tool available we can use directly like that. Not like that. If we are using, if you are generating, if you are creating one decision support system with the help of the explainable AI or generative AI incorporated, if you want to incorporate that part, we have to work for that. Okay, then only it is possible. Okay, so explainable AI will, suppose if you are feeding that already during my explanation, I told that. Okay, suppose if you are feeding one skin image, is there any rashes are there? The red, full red color, okay, or mild red color like that, it is available. So by observing that, it will point out the particular region and it will give the explanation. So the other part of the image, how it is, and the specific part is what is the reason for that. So why we are calling or identifying this image is a deceased, that explanation will be given. How it will be given? With the help of the physician, we have to give the information to the system will give that same, right? Next, please explain basic flow for disease classification using explainable AI. Explainable AI based already, whatever this is already I told you that, na, okay, but just it will observe the image and identify the pixel level of the images, and where it is differentiating that particular pixel level is matching with the our condition, so then it will categorize as this is a diseased and not diseased. Next, another one question: is this method suitable for real-time data, or else how we can apply the real-time data in AI algorithm? So real-time data, already I told you that. Okay, one example I given. So two, three leaf images or two, three kind of images we can give, and the combinations of different data will be created. Dummy data we can create. So text data, suppose if you are giving a sample, these are all the features. You can right now you can check in your LLM. Okay, you can use Gemini AI or any Claude or anyone. Okay, ChatGPT. Just write it. Okay, I need a student record set with the features this roll number, student name, mark, like that. I need 1,000 record, 5,000 record, whatever you are mentioning, it will give. This is the dummy data generation. Okay, so the same thing only. Real time data, how the real time means on time we have to give live data, whatever the weather prediction data is available, if you are giving. So this up to this morning to evening up to 5 o'clock, this is the real time data I captured from the my system. So what will be the next up to 8 o'clock, like that, if you are giving into the system, so it will predict according to the available combination, it will guess under the with the reference of past data. So the real time data can be extended with the help of the generative AI also possible. Next, where I got a data set in where I get data, diabetics, so many data set available in UCI machine learning repository, there you can get it, and Gaggle also you can get it. How can explainable AI can be used in intuition detection system? Intuition detection system nowadays, the cyber security analysis, we can use that. Okay, so previously the wired data set, KDD data set used, then NSL KDD came, then XAI, like that. Okay, so many wireless data set introduced after that. Okay, in 2000, 2010 version, 11 version also available, 16 also available. Okay, so many data set available. But this case, this explainable AI, the standard data set aspect. Okay, suppose if you are giving wired data set, for example, wired data set means these are all the already we have fixed that. Okay, these are all the features available. Then this is this type of attack. This is a DOS attack. This is a probe attack. This is U2R, R2L, like that. It will categorize according to the feature value. The same thing in cyber security also, dynamically the data will be generated. Okay, so the because of the so many users, dynamically they are coming and doing different activities that will be observed based on their behavior. Okay, so it will be dynamically, the decision will be taken. He is a malware, he is trying to hack something, he is trying to do something differently, like that it will give. Why? Because he touched this one, he did this one, like that it will give the information. That is the explainable AI. That is possible only in intuition detection system. Next, another one question given, works the algorithm and methodology to design 3D images in brain tumor. I didn't get that question. What sir is asking. Next, do we balance explainability versus patient privacy, especially with the sensitive data like EHR? Yes. So, sir, already we have discussed about that. Okay, the patient privacy will be maintained because of the we are not generating the real one who is having as of now, right? So, generative AI, what it will do, the similar kind of different combination. Okay, that's why I told three images, original images. If you are giving, what are all the possible images can be generated, that will be generated by the system. Okay, that is a different case, right? So that newly generated data may not, okay, will not match the anyone real one. May match one or two persons. Okay, but it is not. It will not match exactly to any particular X and Y and all. Nobody will come and claim this is my data generated by this one and all. Okay, anyhow, we are not collecting the data directly from the particular patient. We used that different combination possibility we have created through the system. So it is okay. So there is no case to affect the patient's privacy, anything and all. Any other question, madam?
No, sir. It was so
Okay.
excellent that you have been answering all the questions which was being
Yes,
asked
ma'am.
by the participants.
Yes, ma'am. Thank you, ma'am.
Thank you, sir.
Thank you, ma'am. Thank you so much, ma'am.
Sir, a few minutes, sir. It's my
Yes,
privilege and honor to thank the guest, Dr. Ganapathy, Associate Professor of NITTR Bhopal, for delivering such an insightful and inspiring lecture. Thank you, sir. His profound knowledge and engaging presentation has truly enriched our understanding and left us motivated. His
Thank you, ma'am.
contributions to the fields of computer science, AI, and technical educations are remarkable, and his passion for advancing the knowledge is truly commendable. A special thanks for you, sir, for joining this session and sharing your knowledge. Thank you. Thanks a lot, sir.
Thank you, ma'am. Shall I leave, ma'am?
Yes, sir. Yes, sir. Thank you. Thank you, sir.
Thank you. Thank you, ma'am. Bye.
Praveen, sir. Praveen, sir. Good evening, sir. Good evening, Ramaiah, sir.
Good evening.
Sir, shall we start, sir?
Yeah, we can start.
Yeah, just give me 2 minutes of time.
Sure.
A warm welcome to our guest of Day 4, Session 8, who is an industry person, Mr. Ramaiah Chidambaram, a senior AML consultant and Rapyder Cloud Solutions, Bengaluru. His topic for this FDP today is deploying generative AI at scale, architecture, and best practices. He has started his career as a founder and CEO of Wisfi Robotics Lab from Jan 2019 to February 2022. He worked as head industry 4.0 and IT at Crescent Innovation and Incubation Council and a technical program manager at Intel Corporation. Currently, he is working as senior AI ML consultant at Rapyder Cloud Solutions, Bengaluru. Welcome, sir.
Thank you. Anybody's
Platform
going
is yours,
to
sir, now.
join, or is that everybody's joining through
Sir,
YouTube? Or
it is on YouTube live.
Mhm. Okay, perfect. So I can start, right?
Yes, sir, you can start now, sir.
Okay. Let me share my screen.
You can share, sir. We'll check.
Hmm. So today's topic is like we would like to understand what is generative AI. Most probably everybody will know about what is generative AI, how we can implement, right? But in general, there is a very big difference between prototype as well as uh, making it deployed in a proper production grade workload. So for that, first we need to understand what are the different workflows are in generative AI as well. Uh, what are the industry grade tools are there, and
So sorry for
how?
disturbing you. Is there
Yeah,
any content on your screen except generative AI workflow?
no, I didn't start it.
Yeah. Okay, sir. Just for checking.
So that has to be clearly understood, and then how it has to be deployed in a production grade level to meet the business requirement. Everything is the end result. So first, if you would like to start with in any application, I'm going to start with workflow. Then I would like to show you some live demo also. What we built in the healthcare domain with a generative AI technology. I'll show you the demo, and post that if you would like to start with a problem statement, how you can start and what are the key things you have to be consider while building this solution, and whether cloud would be right, so a right area, or you can deploy it in on-prem or edge. Everything will be discussed. I'll try to squeeze it up within 2 hours at my best. Okay, so first we'll understand the high level workflow. What does the generative application need to be covered and different dimensions of it. So for it, start from user. Let's say, imagine that you are using some application with a generative AI capability. How the workflow will be. First, the user is the starting point. They are getting into any application where generative workloads are part of it. Once, if I let's say imagine like you would like to build a RAG based generative AI application for your hospital or any pharmaceutical company, then in the application I'm asking some question about any recent test which we done on this particular drug. So can you share the result of that particular drug test, something like that. I'm asking some question. So how it will get inside into the API gateway, and what is the process will happen post that. That's what we are going to discuss right now. So once the application is hit the API gateway, it will go to compute. Uh, some script will be there. It can be a agent or it can be a typical prompt management, which will be used to pull LLM from uh, any cloud-based hub like Bedrock for AWS or Azure Foundry for Azure, or it can be pull LLM through some local servers like Olama. It can be anything. So for that we need some compute, and then it will be go in a different aspect. We need to use storage to store the model or store our data informations, whatever things we need to build it in the RAG pipeline. And then knowledge base is one side where we need to make all this information into a embedding stuff. Like we need to make all the data and source as a vector embedding, and then that particular embedding will be pointed into knowledge base where our model will use those information and give a appropriate response for from from the compute side through API gateway to the user. This is the overall workflow for a typical RAG. So where we'll get the information, that's from database. So this is the overall typical RAG system in general. Most of the organization or enterprise or any institution will build a generative AI application to solve their business problem. It can be the knowledge base can be a database, or it can be a PDF or document or Excel file, whatever it is. But this is a high level workflow. Apart from that, few things need to be considered very clearly. One is security, especially if we are dealing with healthcare or any pharmaceutical industry, right? This is very important because um, the compliance like HIPAA compliance or any specific domain specific compliance need to be there. And at the same time, how our data are very secure. For example, for specific R&D level data or any specific regional level data. For example, in India, we are doing some research in pharmaceutical industry. That data should not go out of India region. So likewise, many compliance and security rules will be provided for domain specific, and that governing body specific rules will be there. It can be differ from one country to country, region to region, especially Europe has a very strict compliance in terms of healthcare and finance sector. So these are the based on the region, based on the area which you are going to deploy your workload, you need to take care of the security measures. First, the application level. Second, the regional or government level security and measurements, we need to take care of it. This is very important. And the second stuff is fine tuning. Whenever you would like to build a solution, it's simply getting the information from your knowledge base and responding it to the user. It may not work for everything. For example, you would like to build a virtual assistant for a pharmaceutical company where they would like to uh, use this particular application to interact with the doctor, to understand the tablets or drugs what they are proposing, or what they are selling in the market, right? So in that case, this particular model, the LLM, right, it has to understand some domain specific information also, drug level or any compound level. It should have the domain specific information. For that, we need to fine tune those models. This is the right uh, time to do it, and most of the time we are using SLM. We'll download some large language model or SLM. We'll fine tune according to our domain specific, and we can use it in our organization level application. So this is how the most of the organization are using fine tuning to make excel in their particular domain. And third one, agentic workflow. Right now, it is very popular. Agentic AI as well, AGI, whatever you would like to call it. This complete framework is like where LLM simply give a response, but agent will do some more reasoning. How a human we will think, right? For example, let's say you are holding some object, and you won't drop it just like that. It's based on the object you are holding, whether you are holding a glass bottle or wooden bottle or a stone. Based on that, your response will be differ. So how you are thinking about it, it is purely based on the reasoning, and what you would like to do based on the what situation, right? So that will be uh, taken care by this particular agentic workflow. Simply get the information from the knowledge base and throw it in front of the user, or any task. It's not only retrieving the information from the knowledge base, it can be any task. It has to do some reasoning. Unless until the right output it is coming out of the system, it will do the loop again and again, and it will get the proper result. Then only it will bring it to the user. This everything will happen in a second of fraction of second. So this is how agentic workflow is very important in this particular time of period. And we are going with multi-model multi-agent approach, and different frameworks also coming into picture, right? So this everything can be uh, done, but this is the baseline. Whatever you are seeing in the screen right now is the baseline for all the agentic workflow or AGA, whatever we are discussing right now. It's starting from the RAG pipeline. So if you would like to build a generative AI application as first time, or you would like to try it out in a production grade level, I strongly suggest to build this particular RAG first with a proper production grade measures. Then you can try it out, fine tuning agentic workflow, everything as a next stage. So we should have some component, right? This is high level wireframe. Theoretically, we can understand what compute is, what knowledge bases, etc. But we should know what exactly these tools are used, what kind of tools are used for these each and every stage, right? So I'm going to take AWS as one example, because AWS is one of the topmost cloud in the market, where we can deploy our industry based or real time workloads, right? So I'm going to give you some idea what are the different components are used for these every stages, right? So first, API gateway. AWS itself has a dedicated API gateway where you can configure in your console itself. And then compute, we have multiple option. Whatever you are seeing here is AWS Lambda, but this is serverless, where whenever the request comes, this will be get triggered and use models and storage, knowledge base, etc. But we have another one compute called EC2. These are the these two are very commonly used compute, but EC2 is like a server virtual machine where 24/7 it will continuously run, or whenever you would like to turn on, you can turn on, or turn off, you can turn off. Uh, but this one is serverless, the Lambda. Whenever the request comes, automatically the server will get triggered and it will do the job. Whenever the request completed, automatically it will shut down. So whenever you have a less request, for example, your traffic for your application is very less, you can use Lambda. Whenever your traffic for your application is huge, you can go for virtual machine. And storage, to store the datas or maybe the documents like PDF, Excel kind of object based document, you can use S3 bucket. Whenever you would like to store the complete history about the whole conversation, like users are talking about some frequent questions, and according to that the application is responding, you would like to capture the complete log whatever happening in this particular application. Those kind of logs can be stored in DynamoDB kind of a databases. Or this is more into storage level. And knowledge base, you can build it in many way. Here, whatever you are seeing, model, knowledge base, and database, and these things, right? Apart from database, the knowledge base and model, this will be covered under Bedrock. So Bedrock is one of the component in AWS where it's a single point of tool or single umbrella for the entire generative AI workloads. If possible, I'll also open in the AWS console and I'll show it to you what are the things available, how it can be used and all. So this is how you'll build some real world GenAI solution. And before going to the AWS console and showing everything, I would like to show you the demo straightforward. Whatever how it is working in whatever the application level we can do. Post that, I'll go to AWS console as well as I'm showing you one by one, right? So and whenever we would like to build a solution, right? Let's say we'll go for a demo. I'll show you a demo first. Then we'll come to this particular area. I'll give you more overview about it. Hope you can see my browser screen, right? Can anyone confirm? Hello? Hello? Can anyone confirm? Can you see the browser screen? Okay. This particular platform is call it as a tech studio, where in our Rapyder we have a entire solutions what we build to showcase to the customer as a demo. We keep this particular platform where it's a customer facing platform only. You can also go and explore by register by yourself. Here I'll come into healthcare. I'm going to show you one or two sample for you how it will work, how it is working. I'll go for a cure company in AI. For this particular GenAI application is right. This is a very straightforward RAG application, whichever I shown you right now as a base. Let's say a hospital, uh, chain of hospital organization or institution, they would like to build a generative AI application for the customer facing or the patient facing, where with a three intent. They can the general customer can come into this virtual assistant. They can ask some question about any medical issue, like I have a symptoms for cancer. Can you share the symptom for cancer? Or I have the symptoms. What would be the issue? That kind of a general medical question they can ask, or they can ask some organization level or hospital level informations also. I have a nerve issue. Can you suggest some doctors in this particular location? That level also they can ask some question. And even one level above, if it is a registered patient or they are regular patient, then they can log in into the system by through OTP authentication, etc. And then they can ask account level information where they can get their previous prescription or lab report. Those kind of information also they can get through this assistant. I'll just try it now. For example, this is the UI where I can ask my questions. For example, I'm asking, can you share symptoms for cancer? You can go with a general English or natural language query. It might understand it very clearly, and according to that, it will give a response. So you can see that I understand you are asking for about symptoms of cancer. It's important to note that the cancer symptoms and it giving a symptoms for whatever the cancer is providing. So I'm asking, can you please share share the doctors to consult my nerve issue. Okay, this particular query is very account level specific or the organization level specific. This particular information will be fetched from the knowledge base what this particular hospital has. It is not the general information available in the internet. For example, in our database in the back, we gave some dummy data for this demo. So it is identifying specific doctors who are relevant to neurology. So it is listing their name and their year of experience, specialization, success rate, and what time they will be available. This information it's providing. Likewise, it can be right now it is not directly connected with the database, but it can possible. It can be done for sure. So you can connect this particular virtual assistant to the database, and you can ask some query which can be responded in real time. For example, here this is purely a RAG where we are asking some questions in the natural language level. LLM is going and getting the right appropriate information through the vector database. But in the other side, if you would like to get the real-time information, LLMs will be used to convert the natural language query into a SQL query, and that SQL query will be run on the database and it will do the SQL job, and then it will get the information table, and then the table will be coming to the LLM and will be converted into a natural language level response and coming to the user. So this is the way also you can work on, so that in real time for 10 minutes before or 15 minutes before some lab reports are updated in the system for you, then you can ask those information in the virtual assistant. It can give in real time. That is also possible. Okay, so I hope this particular demo will be really helpful for you to seeing it in a real use case, how it is used in the real time healthcare domain. And even another one interesting use case I would like to show is Mediscan AI. For example, let me open it up. So this particular solution application is, you can scan any medical imaging, and it will, in the back end it is running large vision model, where it can analyze medical images and give some response, or diagnose something and give a detailed explanation or some brief summary about that particular medical images. For example, I'm taking some sample stuff like CT scan. You can take some samples also. This is the sample image. I'm going to analyze. I'm just click analyzing. So generative AI, nothing but every time it has to be a chatbot where you can upload this kind of information, and in the back end it do some analysis and give you the generative content, which is analyzed based on the input what you provided. So previously it was text to text. This is image to text, where it's like a multimodal, where we will call it as a large vision model plus large text model together. Okay, so analysis result, for example, it is analyzing this image, and it is giving some uh, explanation or some predictive health condition based on this particular medical imaging. For example, it is showing that observed within the brain for Shyama, which could indicate potential stroke also, right? So, and we will give a disclaimer also. This analysis is not a suitable for professional medical advice. Please consult a healthcare provider for accurate and diagnosis and treatment. So this is also very important. This is called responsible AI, or we have to clearly build a AI solution where it should not mislead anybody at any situation. For example, even in the Cure company in AI, I'm asking any question about, can you tell me the weather in Chennai? Okay, you see what it is getting responded. It's clearly saying I am a medical AI assistant and can only provide information related to healthcare and medicine. I'd be happy to help with medical questions you may have. So this is not a very sensitive question, but still, this particular GenAI application is for medical situation or medical industry or medical related query bot. So it should not respond for any general weather related information. So it is clearly denying it. I couldn't answer because I'm a medical AI assistant. So can you provide information related to healthcare and medicine? This is called, we call it as a guardrail. Okay, guardrail means it's like a security guard before and after the input, customer input, or before and after the AI application or GenAI application, where what is the input going inside, that is also can be filtered, and the output, if even though it is in database or even though it is in knowledge base, this particular information should not go outside. You can limit that kind of informations also, based on your organization policy or based on your institutional policy or based on your government policy. You can restrict those information. For that we use guardrail. Likewise, uh, you can build a number of solution, whatever you would like to do. So this is text to text, and this one is image to text. So these are the solutions, sample solution I would like to show you. Meanwhile, how this complete solution is built, whatever I showed you, right? It is completely built through AWS Bedrock capabilities only. I'll show you what are the components are there, right? So if you see here, it is offering model. As I told you, it has a n number of models. It starts from either you can pull ChatGPT or Gemini kind of a direct API based models from their account, or you can get into AWS. You can specifically pull some models which is available in the AWS ecosystem. For example, AWS Bedrock has this number of models. Anthropic is one of the very famous model, Claude Sonnet 4, etc., recently launched in the market. These are the models we can use, or Amazon itself, AWS itself, they have an exclusive model family called Nova. That is also can be used. It has multiple ranges: Nova Micro, Nova Lite, Nova Pro, and Nova Premier, and Nova Canva, Nova Reel. So Nova Canva is to generate image, Nova Reel to generate video. So likewise, these Micro is text to text, as we seen in the Cure company here. Pro is like a multi-model type of models, which can text to image, those kind of response also can be given by this one. So likewise, you can build your application and you can pull the LLM whatever you would like to pull. And this is one option. As I told you, I'm taking AWS as a sample. The same way in Azure, you have Azure Foundry, AI Foundry, where you can pull the n number of model like this. Even Cloud Sonnet will be available in Azure also, and you can pull GPT 4.0 or 3.5 mini through OpenAI models. Everything you can pull. Mistral, Meta, Llama models, which provided by Meta. So these LLM can be pulled through this kind of a hub. Amazon, we are using a Bedrock as a LLM hub to pull this information. Apart from this, it has other options also. Like it has a specific tool to optimize and do fine tuning and guardrails for the responsible AI, where you can limit your information which need to be protected by your organization law or government law. And then finally, you can build your agents or multi agents also within this Bedrock. Everything you would like to build under GenAI layer, this particular Bedrock also will be like a single umbrella for you to provide all tools which is used to build that. Okay. So, but you have these kind of tools in place and everything, right? But still, 95% of generative AI solutions are stuck in POC alone. It is not going to production much. The main reason for that particular is uh, identifying the right use case and what we need to build and what is the thought process or prerequisites we should have in our mind to work on this. That is very important while building architecture or whatever it is. It is very important that what is the use case we are going to do and how we are going to plan that. For example, you have this much knowledge, and specifically based on your knowledge, whether you can take low risk side of a projects or high risk side of a project. I'll give you some example. For example, you know Java very much, or you know some specific subject. Within that subject, this is a center point which you know clearly, right? Lesser than this, you doesn't have any clarity on that, and maybe post that you may not have the clear understanding whether it is right or wrong. So this is the situation. In that case, for example, most of the time in the organization perspective, whenever they are trying to build this particular GenAI application, they might be start with low risk project, where because it is lesser than what they know, or it is within their control. For example, this is a center point where you know from the knowledge perspective. Lesser than that, within that knowledge boundary, they would like to play with building application, even though it is a low risk to fail, or maybe even though it is not successful, it is stuck in POC itself, it's not a very big deal for them. So that level of use case they'll start to build. At that time, the impact won't be more for them, because the the project doesn't impact their solution much, or that doesn't impact their business much, because it is in the low risk category. So even though it is successful, it doesn't help for them, so they won't spend much energy to push into POC to production. And the other side of it, uh, it's completely in terms of learning perspective. For example, I know this much, 50%. More than that, whatever we are trying to build, it will be like a learning curve only. So we doesn't know whether it will work or not, but I can try, or I can explore. I can build something. We can play with that. If it is working fine, I'll use it. Otherwise, I won't care. That kind of a high risk project. So, but most of the time, these are the areas where we will get more out of control situation. So if we go more towards high risk, completely out of our knowledge, then you doesn't know how it work, and you couldn't do any customization or fix if it is going wrong. So that is very risky. And in the other side, it is very close to the low risk. They'll play very safely, and if it is failing also, it doesn't make any difference. So at the same time, it is giving a better result also. It doesn't impact your business, so low impact. So this particular two area, the productivity zone as well as this learning zone, is the right area where you can try your application building, where at least it failed also, you are doing it in the productivity zone, it will give at least a decent impact. If it is not working out, it won't affect you much, because it is not a high risk one. And the other hand, you are building something with a clear understanding. We are trying to learn only. We are not expecting that 100% it will work, or 100% it will go what how we are planning. So the clarity is very clear, and we are not go beyond more than 60% or 70%, which is going out of our control. So this will be a very good area to explore or do some R&Ds and try it out what you would like to do. So this particular zone is the perfect zone where you can try your GenAI applications, I would say. Right. So without wasting time, I would like to show you in the console level what are the options are there and how it is working. Right. So let me pull it up. And before going into console, I would like to give you some high level input on what are the few components you need to be taken care while building some AI application in general, because GenAI is also part of AI only. It's a subset. It is not a separate technology. Everybody will focus on this concepts, math, algorithm, and techniques, etc. Especially uh, while we see some stockholders from the institution level or academic level, they will be very excel in this area. uh, but this is one piece of building a AI solution only. The other side, we have softwares like Python, OS, and some libraries, Anaconda or TensorFlow, PyTorch, whatever that will be there. Mostly the corporate people or industry level people who are developing some application, they'll be excel at this particular hands-on software implementation side of it, and little bit about the conceptual level, whatever they need to understand. But these two areas, especially hardware and communication, this is also equally important. And mostly the corporate people, the senior folks, or who are building it for more than 5 years, 6 years, they might have some decent understanding about this APIs and JSON, so communication level protocols which will be used. Uh, but the hardware area is most of the time it's a gray area, because we doesn't even care about it even in our research side, right? Whenever you are getting some research fund to do some machine learning model or GenAI application development, you might have some allocation to purchase hardware also. Straight away we will go and purchase one CPU randomly. So we might think that to run some LLM or to run some machine learning pipeline, we should have a GPU. That's understanding, but that is not the case. Even you can run your workloads on CPU, and very high workloads or above mid-level workloads only need GPU level of requirement. Even GPU also can handle one certain level of workloads only. Post that, we have to use NPU or accelerator, AI accelerator kind of a special hardwares. And even sometime we need to use FPGA kind of a custom accelerator cards to be perform some specific tasks. So choosing the right algorithm is very important. Choosing the right software is very important. The same way, equivalent way, choosing the right hardware is also highly important compared to the right algorithm and right framework, because if you can use same algorithm, same framework, it will give a complete different results in terms of performance, latency, and throughput level whenever you are changing your hardware and you are playing with your hardware. So maybe building a prototype concept and software might be a very good combination or information to be have the clarity. But whenever you are going for a real world project or deploying something in an industry grade level, then you should know about the hardware as well, because this is the commercial. Whenever you are going choosing the right hardware, you can save lot of money without compromising in the application performance. So that is very important. And this is the overall phase where you can start from idea, you can build POC, then go to production. So pilot and MVP are mostly like whenever you have some decent workload to circulate to your internal organization level or some limited employees or limited users, then you can open up to the uh, outside people with limited numbers. So likewise, you can extend your testing phase also. So till this particular POC is very risk. So once it is crossing POC to prototype, it is very easy to move to MVP level also. But this is the very toughest area where POC to production conversion. For that, these things whichever we are talking right now should be carefully followed to make it successful. Okay. And I would like to give very high level input on what is ML, DL, and GenAI split under AI, because everybody talking about ML, DL, GenAI, but it has to be clear definition for it. It doesn't mean that ML is under AI is under ML is under AI, DL is under ML, and GenAI is under DL. So this is very vague or very high level statement, but it has some specific pattern also. It has some specific reason also why we are calling it as a machine learning project, a deep learning project, and GenAI project. For example, whenever you are using a statistic algorithms or statistics models like linear regression or XGBoost kind of a statistics models, then we call those models as a machine learning model. Whenever you are using neural network based models, for example, this statistics models more into structured data or SQL data, or maybe structured data. You can understand, right? MySQL kind of a table format where it has rows and columns. It will be very numeric in nature. It will be easy to calculate with this max and everything. But whenever the social media hype comes, we are dealing with a lot of image based or emoji based or object oriented or some media oriented data is also coming into picture. So these statistics models couldn't perform much accurately in those kind of a media based data sets. So that is why this neural network kind of a techniques evolved. It was already there in 1800 or 1900 itself, but we doesn't have any use case for that. Whenever the say social media or some unstructured data source are increased in the market, this particular deep learning or neural network based models are um, coming into the job to make it work, right? So CNN, RNN kind of a neural network based model, if you are using, then we can call it as a deep learning. And this is an interesting area. Then what is generative AI? So generative AI also nothing but deep learning only. But it has one difference between the deep learning architecture and this one. For example, it is not a separate technology, a separate model comparatively machine learning, deep learning. For example, without deep learning, there is no there is no generative AI, because let's say in ChatGPT also it has around, let's say it has hypothetically it has 300 billion. Out of 300 billion, 1/3 only transformers. 2 by 3rd is completely neural network only. So it is in between neural network architectural neural network layers. This transformer layer also will be inserted to do the performance. So 70 percentage the complete text talk or the layers are covered by uh, deep learning approach or deep learning layers only. Only 25% or 30% is covered by this particular transformer, what we call, which is differentiating GenAI between the deep learning that is used. What exactly it is? For example, in a very simple term, I would say, uh, in general, before generative AI, we keep keyword as the pattern to search something. For example, I am searching it as a I love Apple. So Apple is the keyword, right? But it doesn't know the context behind it. But in generative AI, it can understand the context behind it. For example, I am a foodie. I'm saying I love Apple. Then it will understand that the apple is a fruit in this particular context. And in the other side, I'm saying I love Apple. I'm a techie or I'm a technology person. Then the Apple is electronic device. So likewise, it can understand the context. This is one side of it. In the other side, how it is calculating to make every letter, every word with a vector value. For example, uh, male, that word has some vector value. Female, that word has a vector value. Okay, the same way, boy and girl, these two words has a vector value. Let's say male has I'm saying very hypothetically, just for easy understanding. Let's say male has a vector value of 100, female has a vector value of 200. The difference between male and 200 is 100, right? 100, the value is 100. The same way, boy and girl, the two difference between these two vector values also very similar to the difference what we are seeing in the female and male value. So it is correlate between words similarity also. So this is what we call it as a semantic search, or we would say this is what transform is also doing in the backend to understand the context beyond the words keyword. So this is how it exactly differentiating, and this is one key stuff. And second, very importantly, these models, LLMs or LVM or LLMs, which we are talking about, it's completely trained on global data. It is trained on trillions of data, right? So we can't even imagine how much data it's got trained. So it knows the complete global information. At the same time, it knows the context as well. This makes the magic for generative AI kind of chat GPT or Gemini kind of a models to perform. So if you are doing some project only with a statistics model, even though you are doing some any sort of a use case, it doesn't mean it doesn't value what use case you are doing. Simply, if you are using statistics model to solve something, you are doing a machine learning project. If you are using neural network to solve something, you are doing a deep learning project. It might be a forecasting also, but if you're using neural network, that's a deep learning project. If you're using transformer based architectures, models like Bird or Gemini or any chat GPT or Olama based open source model like Llama, Mistral, then it is like it's a generative AI project. So that level we should have a clear understanding. And I'll whatever I shown you right now is it's a production grade application which we are showcasing to the real industries outside. And I would like to show some prototype level or some academic level project as well. For example, you no need to have a AWS account or any cloud account or any server to be done some GenAI applications. You can do some simple application within your PC if it has some decent hardware. Okay, for example, i7 or i5 with 16 GB RAM. Also, you can try some lower models like 1.5 billion model. Even DeepSeek also has 1.5 billion model. That is, if it is coming around less than a 2 GB of model size, that you can download Llama and you can build your own application also. I would like to show you some demo right away, which used for building some GenAI application, comparing different models locally. Okay, by running uh, um, local models like Olama through Olama, local models like Llama, Mistral kind of a models, and it pull the API based models like Gemini also. Let me open up, and this is completely running in my local laptop itself. I'm not using any internet. I can turn off the internet and show a demo, but you people couldn't see. In general, whenever I'm showing this demo, I'll turn off my internet and show them, because it will make them clear that it is not using internet, it is using my internal uh, infrastructure to see this. For example, this is the structure. This is a very prototype level project. This is not a production grade stuff. I simply pull few LLMs into my local disk, and I create a simple chat interface with Streamlight application, and I wrap up those models with some application along with Fast API server to connect with the local host and try it in the browser. This is what I did, and it will simply compare different model performance for the same prompt. That is what it will do. Forget about how it is done, etc. Like I'll simply run this particular application, so we'll come to know how it works. Let's say, for example, I would like to run this server. First, I have to run this Fast API server, where before that, what I'll do, I have to make sure that it is in the proper folder where my file is placed. Right now, it is in development, so I'm going to deployment. Okay, now I can run this server. So server app reload. Okay. Oops. Let me. Okay, that is not unicorn. That is vcon. Okay. So the server is running right now. This is Fast API. We have multiple. We can use multiple model server. Fast API is one of the prototype level model servers. Whenever we are going for a production, we can use model server uh, 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 like PyTorch based PyServe, or TensorFlow based model server, or even in a very production grade level or very stable level, you can use Trident kind of a model server, which is NVIDIA is offering. Uh, you have different option, but Fast API, if you're trying first time, or if you'd like to build some prototype level application, Fast API is the right model server to use. I'm not going in detail what are the libraries or what are the tools I used in this, because it might take the kill the time. So I would like to move faster. I would like to show you some application can be GenAI application can be run within local system itself without using any high-end server or any cloud-based architectures, etc. For example, here I build this particular Fast API. You can see here, this is the project name I gave for this particular server. This API server, I would say. So this is my complete schema, and API configuration, API informations are there. Simply, I would like to, now my server is activated. Now I can run my application and I can test stuff. So I'm opening another terminal here. This is my client.py is my application file, where I have the Streamlight running, and I created some UI based on Streamlight also. I'm using three models: Llama 3.2 1 billion, DeepSeek R1 1.5 billion, and Gemini 2.5 Flash. This Gemini 2.5 Flash is it is happening through API key. It is connected in through internet. This Llama 3.2 and DeepSeek, these two models are running locally in my disk through Olama server. Okay. If you can see here, my Olama server is also there. So through Olama server only, these two models are getting invoked. Let's see. So I'm going to run this particular file. So I have to go to 1 second. So I have to go to deployment first, then Streamlight and client.py. So if I start the application, it will run because my server is in on stage right now. If you can see here, parallelly, I'm running my server. Still, my server is running. You can see this is the API, this is the IP address, my local host, local IP address is running here. For example, I can whatever information I would like to understand. Maybe what is the security we need to do while building healthcare. Okay, we'll simply ask this question to the model. Different model might give a different response. First, it is running through Gemini 2.5 Flash. Let it run because this will use internet, so it might take some time to get the response. It is giving a response from Gemini 2.5 Flash. Building a GenAI application in healthcare high risk. So it's secure healthcare information, product healthcare information, and it is clearly saying that I told you right. It needs some compliance need to be done. So foundational healthcare security and compliances like HIPAA compliance and high tech GDPR. These kind of a compliance need to be taken care. So HIPAA compliance for US based stuff. This is a globally accepted compliance for healthcare side, and international regulation GDPR. This is exclusively for Europe Union, and CCPA for California, and PIPDA is for Canada. Likewise, many compliances you have to take. So need to be considered while building this kind of application. So let's say we'll see another model. I'm going to use DeepSeek R1 1.5 billion. So right now that is in my local host that is running locally in my machine. If you see the taskbar, might be you can come to know. You see here my memory is showing 11.5 after I started this search, right? So because right now this particular model is utilizing my RAM to give the response completely. Let's see how much time it will take. We'll wait for a second because it's a huge question which I asked. In the sense, for this model, it is heavy only. We'll see whether it is taking more time. We'll skip. Otherwise, we'll see. That's a problem. You are running it in local, so it will take some time. It is based on how many applications you are running currently in your system. Also, I have many applications opened already, so it is struggle to give the answer in a faster speed, in a good speed. So right now you are seeing the response from DeepSeek R1 1.5 billion. So if you can see here, it is giving a different perspective. So understand the data protection laws. In a high level, it gave HIPAA everything. So it's showing that data encryption. So you have to encrypt your data, and then you have to check your data architecture. First, you have to understand because without data, you couldn't build your GenAI or AI application. So understanding the data is very important, and building a good data foundation is very important. So that is what it is pointing in the third level. And fourth, secure coding practice. So code level, it should not leak anything. And then in general, whatever we discussed previously, security measure as well as access control whenever it is used by any user, etc., etc. Right. So this is a simple application we build locally. Right now, if you see here, still the model is getting used. I can also just check by running my PowerShell whether with this model is running or not. For example, I'm opening my PowerShell, I'm typing Olama, so it is giving a list of commands how to check everything. For example, uh, list model, list running model. I'm going to type PS, Olama PS. So it's showing, see, I just used DeepSeek R1 1.5 billion. So this is the model I used. So it is showing around 1.5 billion. Right now I'm choosing the Llama 3.2 also. It will start using it. You can, meanwhile, you can see the response from Olama also. It will show again. It is Llama also used. For example, I'm typing the same command again. So now you see, now DeepSeek is not there. Now it is showing Llama 3.21 billion, because right now I'm using Llama 3.1 billion only to use this response. 100% CPU utilization, and it is giving in 4 minutes from whatever using. So it is giving a different response right now altogether. I didn't change the prompt for any model. So the same prompt with the different models are giving different responses. Cool. So in a same way, you can build your applications based on the models you would like to play with. And if you would like to check in Olama, it has n number of models available. So I just use only 2 models just for usage level, just to try it out. But you have n number of models. You can see here everything is models only. So I used Llama 3, Mistral I downloaded but I didn't use, but whatever DeepSeek R1, under that it has many. For example, which I used is 1.5 billion, that's a 1.1 GB model. It has up to 404 GB model also there. If you would like to run this, then you need a very big server or GPU to run that. Or even for 20 GB, 30, 40 GB models also, you need a GPU or very high compute machine to run. So likewise, based on the model size and model thing, you can think about it. Maybe you can search for healthcare related models also. Any healthcare based models you'd like to check, you can also check whether it is available or not. See, this is something relevant to medical communication, diagnosis, patient care with advanced capability. Some flavored models also available exclusively for medical related stuff. So you can download these models, you can do the benchmarking and you can test it out. It is only showing 3.8 billion. So it is saying Medix PH is the state of the art language model specialized for the healthcare industry in the Philippine enhancing medical communication. So likewise, you can also explore. This is Olama as one level. If you like to more than that, you can go to Hugging Face, where you can found lakhs of models available there. Indian based, Indian regional based models or voice based model, healthcare related model, anything. It has around, if I'm not wrong, it has 2 lakh models. Sorry, 20 lakhs models are available right now in this particular Hugging Face. So any model you can pull. It's not straightforward like Olama. So you have to know some script level or code level how you have to pull this kind of Hugging Face model into your local machine to do something. Olama is very straightforward at the initial level. Okay, so these are the very good industry practices where are some structures or workflow whenever you would like to build a GenAI application in your local or in the cloud or etc. Maybe if you would like to build something very realistic or in the real world level, right? I would say have the detailed understanding about the hardware layers. This is very important, as I told you. Then only you can identify the right hardware for your right application. Forget about the brand and architecture and all. Majorly, it has personal computer. This is more of laptop kind of a thing where we can do some testing, prototypes, etc. Edge computing server is real hardware where we can deploy our uh, industry grade or real world deployment where we can do. For example, servers, it has 2 options. One is cloud. another one is data center. Both are servers only, same server, but how it is connected together and what sort of a infrastructure it is, how scalable it is, that's a differentiation between data center and the cloud like AWS or Azure. Okay, I don't want to get into more detail what is cloud, what is data center, what is the difference between edge computing and all. Maybe if time permit, later period, maybe you can also connect with me in LinkedIn. This is my LinkedIn profile. Maybe you can ask your doubt. I'll also try to connect with you and explain you in detail offline. Okay, so it is very important to understand some hardware level uh, tech specs as well. For example, we might know i7 processor 13th generation. That level we'll check to buy. We'll check hardwares whenever we buy laptop. But post that, this is not the only stuff. For example, even i7 13th generation also will have 10 core or 8 core, which even within number of core itself, it has some performance core and efficiency cores also. That will be defined by these kind of processor numbers. For example, here it is pointing as a H, right? My particular system right now, it has a H. The CPU is H series CPU 13620H. It has overall it has 10 cores. If you go and check this particular processor detailing, right, in the internet, you will come to know how many performance core as well, how many efficiency cores are available through the Intel, the manufacturer itself. For example, I'm opening this, you will come to know how many performance core. For example, out of 10 core, 6 performance core and 4 efficiency core. Instead of this H series, it has P series and U series also. U is the very uh, efficiency level series where out of this 10, only 2 core will be performance core, 8 core will be efficient cores. So performance core is the best core to run heavy work ML or graphic level workloads or some reasoning workloads. Efficient cores are mostly for MS Office or kind of a normal office related or lightweight applications to run. That's where we need to check hardware. i7 13th gen, we have 3 categories also, H, U, P. So H is the highly efficient or performance based core, and U is the efficient core. You can check your laptop whether you have a H series or P series or U series. If you have U series, probably your performance core will be very less, efficiency core will be high, even though you have 10 core also. This is simple for CPU itself, for our laptop itself. Then you imagine how much complications will be or how much detailing will be to choose servers or any edge devices or any cloud computing instances and all. So that is why I'm telling you it is very important to understand what is the hardware and what is the tech spec behind the hardware before running your workloads. So if you are, I'll very quickly give you when you can use cloud and when you can use data center, when you can use edge, by considering the time in mind. So while you would like to testing something idea level, you can use your laptop or PC. And whenever it is going beyond the capacity, for example, you're even though you are using i7 laptop, I'm using i7 laptop, it has only 10 cores and RAM, I have a 16 GB RAM. Maybe if I would like to run DeepSeek R1 25 GB, 23 GB model, my RAM couldn't support because it will overflow. CPU also doesn't work, it will overflow. Then I need to connect with data center. If I have something in my college or in my company, I can connect with it. This will be I don't need to have an internet. It will, if I'm connected in the same network where the server is connected, I can access that and I can use this. I don't need to pay separately because we already invested to do this kind of a process from organization level or institution level, or I can purchase one server also for me. I don't need to pay monthly bill or yearly bill for usage because that is my server. I'm giving a one-time investment, I'm doing it. The other side, I'm not going to use very frequently. Whenever I'll be using it very rarely, then no need to, there is no sense, no meaning to buy a server. At the time, you can use cloud. Let's say in a month you are using 10 hours, you can only pay for the 10 hours, you can close that and you can come out and you can do your other job. Whenever needed, you can go and grab it, and once you are done it, you close it, you pay what you used. Likewise, you can use, so this is the way you can use cloud and data center to testing it out. From the production side or the real time, real world deployment, whenever your clients are worldwide or out of your region, out of your institution, then the particular workload or application should be in cloud. Then only the people can connect through internet, right? But you are trying to build something for your organization or your institution level user or organization level user in a private level, then you can run the workload in the server where all people connected in that network have access. Then straightforward they can use that particular server to connect with that particular ML application or GenAI application. They can use it out. Edges where you have to deploy it locally. For example, one of the case study I would say, like previously I did one freelance consulting project for building some sports coach assistant. For example, one of the organization or one of the company are building AI based or deep learning based solution where they can capture the player's posture. Let's say shuttle game is the example or tennis is the example. Based on the player playing a game, by capturing the video itself, in the video we can understand how they are playing and how effectively they are taking steps and how effectively they are covering the court, etc. We can capture through video itself based on their body posture, their movement and their ankle position, etc. So we will capture those information. According to that, this will give a insights like a coach. If one coach is seeing that particular game and giving a feedback, in this particular set you did this particular mistake, based on the because of that only you are lost that particular set. The same way this particular deep learning system observe based on the video, and it will give an insight to the player. So for this, response is very important. The model should be in the ground itself. If it is in the cloud or in the data center, the response time will be huge, because it has to connect with the local internet, then it has to connect to cloud, it has to come back, and even though it is in seconds, even though it is in less than a minute, 50 second or 40 second or 60 second, based on the streaming internet video, internet speed, as well as streaming data size. But still 50-second or 60-second is also sometime it will create less engagement for the user to get the response. At that time, if we can run the model locally within the ground itself, then less than 10-second or 5-second the response will go to the user. It will give a very good impact and engagement for the user to get the insight. So likewise, for agriculture side, or even within operation theater, you would like to give instruction to doctor, or within any R&D lab, you would like to give a real-time updates, whatever your your clinical experiments are coming out. That level, if you would like to show something in real time, then this kind of edge level device deployment will be helpful for you. So we have multiple combinations also. You can combine cloud plus data center, as well as data center, cloud plus edge, everything. There are different combination we can try it out. But in high level, these are the major thing. Based on your requirement, you can customize things and all. Parallelly, if you would like to see cloud, this is the AWS console which I'm seeing here. Let's say, for example, I told you, right, multiple servers are there. Even within AWS ecosystem itself, this many servers are there. Each and every, whatever you are seeing here, M6G, M6I, M6I, and everything is different instance only. For individual instance, it has a separate tech stocks and separate memory configuration, separate pricing. If you exclusively want some compute based server, then it has a separate list is there. You want more RAM capacity, less compute, that is also there. If you need accelerator level, GPU level, or this is a latest GPU, Blackwell, provided by superchips provided by NVIDIA. This is the world's latest or number one supercomputer or single supercomputer, I would say, graphics, right? Apart from quantum chips or quantum computers, from the architecture, what we are using, ARM architecture based or 86 architecture based, this is the best or the number one. So likewise, a number of instances also there, like exclusive, as I told you, FPGA based accelerators are also there, and some exclusive something where I would say like uh, accelerators, exclusively AI based accelerators, like Gaudi AI accelerators from Habana Labs. It's a Intel's company. This is exclusive accelerator for AI with very high compute requirement, or HPC, high performance computing level. The same way Qualcomm also has some Qualcomm AI 100 accelerator chip. Likewise, n number of options you have. So you need to understand the hardware a little bit if you would like to do some real-time deployment. And apart from that, in this AWS itself, as I told you, many services also available. For example, EC2, which we seen right now. And apart from that, like if you would like to see Bedrock, which we talked about, generative AI, this is a complete ecosystem for building a generative AI or agentic solutions from your side itself. So if you can see here, these are the complete uh, console where you can build your stuff. It has some playgrounds also. You can choose your model. For example, I'm going to choose Anthropic Claude 3 Sonnet. Okay, just I'm saying hi, so it will give some response to me. Okay, what I can do is I can compare two models together. So from here itself, I can compare another one, DeepSeek, maybe DeepSeek R1. Okay, so I can give hi with the same default. So we can see this is giving a response, this is also giving a response. If you can see here, it is comparing how fast these models are giving a response. Claude 3 CNET is giving uh, uh, 8500 millisecond. This is giving approximate very high in response time, but it is doing more reasoning compared to Claude Sonnet. Likewise, you can compare many things. Even you can build your agents are here. You can build your agents with some basic LLM to be part of it, the guardrail which I pointed you, and prompt management, everything you can build it within this particular Bedrock ecosystem itself. You would like to build something knowledge base, you can connect your databases along with knowledge base. So likewise, you can build your entire GenAI solution, including agents and including multi-agent, everything you can do it in Bedrock. The same way, if you'd like to see in Azure side of it, Azure Foundry AI is the area where you can build your whole ecosystem. Okay, so different models also will be available there. Let's say here the models will be custom model list, import models, right? This is to import models. This is a model catalog. Whatever the models available, we can see here. This number of models are available. Amazon side, Anthropic, Claude, Sonnet 4.1, Opus 4.1, for Sonnet 4, 3.7, etc. Model access, you have to first request for access whenever you would like to build a solution using specific models. I already using all many of the models, so I got the grant access for most of the models here. So if you would like to start first, you have to get the access request. That doesn't cost you anything. Post that, you can use it in your application. Whenever you're using model in your application, for that only you will get built. Okay. Okay. I hope I gave a detailed input across starting from workflow to till what are the tools can be used and how the enterprise level applications are there. and what are the good practices we have to do, and maybe in locally or cloud level, what are the things you need to be consider. I won't say I'm educating to you or giving a training to you, because within 1.5 hours I couldn't educate you anything. I gave you some spark to you, and I throw you a lot of information in front of you where you can go look into and improve your skills or improve your resource based on your requirement. So 360-degree, I throw a lot of information and shown you some demos and shown you something in live to give you some confidence and motivate you. This can be done also. I hope you will explore from your side and do some reasonable stuff in your domain. And all the best to everyone. And over to you. And I would like
Sir,
to thank Praveen as well,
sir, there are
Professor
certain
Praveen
questions
as
which
well
have been
as
posted.
Professor Praveen
Ramaiah,
as
sir.
well as NIT Puducherry for this opportunity as well.
Ramaiah, sir, am I audible?
Yeah, you're audible.
Yeah, sir, certain questions are being posted in MS Teams which are being asked by the participants in the YouTube.
Okay.
You can see in the chat of that MS Teams.
Okay, I'm reading it right now.
Yes, sir.
So, Rainy, can we give multiple images at same time? Example, 45 images. Yeah, it is possible. Not only 45 images, you can, this is what we call it as a throughput. How much images you can, how much image or how much workload you can process parallelly or seriously, right? So at a time, how much you can run. That is throughput. For one running a single workload, uh, the round response time, that is latency. So 45 images are very less. We can even run 5,000 images or 10,000 images or even 1,000 images, more than that also. That is completely based on your GPU capacity. Whenever you're coming to images without GPU, you couldn't do. So as I told you, in the AWS side, right? If you can see here, it has n number of memory optimized or accelerated optimized. So if you'd like to start with the GPU side, for example, image based any analysis, or you would like to do something, G4DN is the right instance, I would say. It will be starts from 16 GB RAM, just 16 GB GPU memory, 24 GB, multiple options also there. You can try it out, but it is possible. Even you can run 1,000 images at a time also. And another one question is, GenAI workloads on statistical data, neural network versus transform. Explain in detail. How do they differ? Is GenAI works on statistical data? Okay, GenAI, as I told you, statistical algorithm. It is not about data. Data, it can be anything. Statistical data or media unstructured data, or it can be a voice or it can be image. That is not a big deal. If you would like to classify based on the technology, whether GenAI or deep learning or machine learning, rather than data, it is very important what is the brain you are using. Brain in the sense algorithm. What type of algorithm you are choosing. If you are choosing statistical algorithms like linear regression, kind of a traditional algorithms, classic machine learning algorithm, then it's a machine learning. GenAI means it has to support transformer based architecture models as a foundation model. Either you have to use BERT kind of models or GPT kind of a models to be running into it. Neural network versus transformer. I already told you, in a high level, semantic search, transformer side, it knows a context behind it at, and vectorizing the words is very important, the transformer. But it's a very big topic to go in detail. Maybe we can connect offline through LinkedIn, or you can also explore in internet. You have a number of resources also available to explain in detail, or you can connect with me in LinkedIn. I can also share you some references for you to learn more. What is the purpose of involving transformer in deep learning, and how it shows the difference for generative AI? Najama Sultana. So that's what I told you, right? Transformer, it's giving a difference to understand the context behind the keyword. Let's say, for example, I told you, right? So the vectoring the words, male and female, these two are opposite. Transformer can understand, but normal deep learning couldn't understand. That is a difference between Grammarly and ChatGPT. Grammarly also generating something. We know that we are using Grammarly uh, uh, from very earlier stages in email or in Word, etc. It will automatically guess the next word and it will give. But ChatGPT also doing the same, but it knows the context because of the transformer. It knows what male and female are opposite words, and male and boy are similar words. Kind of, it know the vector between these. It know the vector value between these two words, so it can understand the relationship between the words. That's a difference between the typical deep learning and transformer based models. And it is trained in the large models, large data sets also globally. So that's one of the difference. And Vinay, what are the limitations of transformer based generative AI? Uh, it just depends that we couldn't say that this is the limitation. It depends on the model. It depends on the type of transformer based models. Like LLM couldn't support media files, or LVM couldn't support multi text and video together. This is a very general stuff, but Anthropic Claude Sonnet has a different limitations. ChatGPT has a different limitation. Gemini has a limitation. We couldn't say this is the limitation for transformer, because that is the age we are right now. Maybe you can compare agentic AI with generating AI, because reasoning is not happening in generative AI, but agentic AI reasoning is happening. But that is also foundation is the brain is transformer based models only. Top of that, we are building some system to make the model think something beyond generative AI or typical LLM to do some reasoning. And Bhavani Shankar, GenBot is similar to other chatbots application. Yeah, this is very similar. Which I guess you are pointing whatever I shown demo locally GenBot. I simply pull models to my application and run it in my local host. That's it. I'm not doing anything. I'm not building any model. I'm using the model like Gemini, Llama, or Mistral kind of models, and making it as application where customizedly based on my request or my taste, I'm using it. But the beauty is, I'm not completely depend on the API call based or internet based connectivity. I'm running a few models locally in my system, and I'm using it. So data also won't go out of my PC, because model is also within my PC itself, and I no need to have an internet also. So I no need to spend any money also, because it is running in my system only. So that you have a limitation in the hardware side. You have a limitation based on the hardware size only. You can choose your models. And Amit Kumar Sharma, neural network and transformer are differ. Okay, yeah, I already told. I already clarified also. Um, can you mention which model may be suitable for analyzing mental health for text, such a diary entries? Seriously, I don't know, because as I pointed you, 2 lakhs plus models are there. But if you ask me what is the top 3 models you can experiment with your production grade application, maybe it can be suitable for any sort of a production grade application. First, I would say GPT-4o kind of a models, OpenAI based models. Second, Anthropic based models like Claude Sonnet 4. Recently, it's launched for 3.5, 3.7 is there. And third one is Nova Pro, Amazon based one, Nova Pro and Nova Micro and all. If you are asking me in open source, these three are, you have to pay for every request, token size level, you have to pay for it. If you ask me open source level, first I would say Mistral is one of the model, and second one is Llama 3.2 or DeepSeek. These kind of models you can get it open source without any cost. You need to have the infrastructure to run it. This kind of a use case also can be built from those models for sure. Abhirami K, if possible, kindly share the workflow for building the model as a document so that we can try building our own models. Sure. Few presentations which presentation and information which I showed you, I couldn't share directly. Maybe you can connect with me through LinkedIn. I can give you some references or article which is available publicly, or I also posted something in my LinkedIn. You can also explore that. That will be really helpful for you. And then Dr. Ramalakshmi, how do transformer-based architecture influence scaling strategies in deployment? Okay, so for example, scaling strategies in deployment is not based on the transformer based architecture, or it is not based on the any model, because model is the model couldn't scale actually. It doesn't work in that way. We need to scale it using some Kubernetes approach, or in the AWS side, one tool called Elastic Container Services, where you can Dockerize your model and keep your Docker image in the container. The ECS service will deploy or terminate the container based on the traffics. So it will do the automatic scaling for you. This is more of an infrastructure side of it, not from the model side capability, scalability for the deployment perspective. But the combination is Docker plus Kubernetes, sorry, Docker plus any ECS kind of a tool, or Docker plus Kubernetes approach. That's the scalability. If you go any cloud, this is the only solution. Jagan Mohan, will there be any replacement for these AI tools? Who knows? I doesn't know. At this time, it is these tools are there. In later period, we may not. We might have different tools, or we at this moment I doesn't know. These are things we have every week or every day. New tools are coming into the picture, especially coming into AI and this particular agentic side. But this is not going to stop straightforward. I'll tell you right now, we are talking about generative AI, but that is already getting outdated. Agentic AI, agentic AGI or agentic AI, that is coming into picture right now. In the next level, ASI is coming. Artificial supernatural intelligence kind of areas or frameworks are also coming in. And to the core, quantum plus AI is the magic actually. So whenever the quantum hardware launched, quantum hardware coming into the market, quantum hardware plus AI framework or AI is like a, I don't know how it is going to change the industry altogether. It might be equivalent to the electricity invention. That level, it might completely change the whole industry and the scenario. It has a very big possibilities. Luckily, hope we will be there to see what is going to happen in 10-15 years. And finally, Navdeep, I have a trained deep learning model. Can you suggest a good resource or guide that explains the proper steps for deploying it? I want to make the model accessible from both a website and a mobile app. That's a typical question, how to deploy your model, right? So maybe guide in the sense, I don't know, I can share you some references for you. And even if you need any inputs, I can also give you some inputs based on my bandwidth also. Connect with me offline. I'll give you some inputs. I'll share you some references. We'll see how it works, how it helps for you.
Thank you,
Thank you so
Ramaiah,
much.
sir. Thank you, sir. So on behalf of our institute, we organizers thank you actually for accepting our invitation. Your deep insights into the architectural considerations like scaling strength, strategies, and practical best practices are very informative, sir. The generative AI, you have been extremely given a valuable inputs, and you are not only highlighted the challenges in scaling models to production environments, but also shared some approaches on infrastructure and responsible AI practices. So generative AI is shaping the industries nowadays, and today's session has given us both the vision and practical roadmap of its potential responsible of the scale. I think the participants would have gained more knowledge on what industries are doing on this and how you have deployed, and all these information will be valuable to us. Thank you, sir.
Thank you so much.
Thanks a lot for sharing your time with us, sir.
Thank you.
Thank you, sir.